voice test 111. Voice test 111. Okay, that. Yeah, so the challenge has already opened up. Let me just post an update. I'm gonna say live now. This is that there. Yep. Okay. Um. So yeah. So before we get started with with the with the today's like new puzzle, I think we can open it. But yeah, I guess we can look at the updates to our leaderboard. I think leaderboardaችን ላይ ብዙ ሰዎች ገብተዋል. So we are up to like 16 or 17 people. 17 ሰዎች አሉ leaderboardaችን ላይ. And let's go back to the so አዲሱ ቻሌንጅ አሁን like ከአምስት ደቂቃ በፊት ተከፍቷል. So we can work on that. But before we get started working on that, I need to do this. Let me just create the advent of code. I need to talk about something, some change I made to yesterday's solution. So if I open part 2, or let me get the diff, it will be easier to explain with the diff. I went on to refactor this code, but basically, so previously yesterday to calculate the chunk sizes, because in yesterday's challenge, if I go back, የትናንትናው challenge ላይ, especially in part 2, we are basically asked to chunk the string up into different chunks, and then basically compare that. So our solution was it followed that pattern. So we used the list.size the chunk function to group them into like a specific index, and then this index is invalid function is gonna be recursed, like it's a recursive function. So መጀመሪያ ሲጠራ it gets called with 1. If I open it here, I need to move this next to this, and if I go to parts -2 dio2, so is invalid. Yeah, so these are like in invalid IDs the list that gets the function that gets called with each range, and then gets the list of all the invalid IDs. And is invalid function ይጠራል. is invalid takes in the current number. We want like range just increment እያደረግን range ውስጥ ያሉትን numbers በሙሉ cover እናደርጋለን, and then first we call it with 1. So here the chunk size will be 1. ከዛ በኋላ in our previous code we were turning the current integer into a string, and then getting all the and then we turn it into a string, and then we turn it to a list of characters. That's what this two graphemes does. So and then we chunk. So once we get that list, the list ካገኘን በኋላ size the chunk የሚል function አግኝተን ከዛ we group them into, for example, if this is 1, this will group the list into sublists with one length each, and then if it was 2, it will group them into 2 lengths each, and then basically we take the first one, and then we check that all of them are equal to the first one, because that's basically the requirement here. So yeah, so that was how it was working. So I talked about yesterday that I didn't like the fact that we are converting this into a string. So I came up with a new solution. So the first thing, ዋናው ነገር የሚያስፈልገን ይሄ ነበረ, split int የሚል function. So basically what this does is, given I'm gonna comment this out and say, given a number like this, so if you give it 42 and then pass in 2, this is what will end up happening. So this is an int power function. They didn't have an int power function in Gleam, so I had to create one, but we can ignore that. So it's basically gonna and then you have to say, I guess, 2, but the position counting starts from the right, because we're gonna be using this to split. Yeah, but that doesn't really matter. So we don't start counting 1 from the left side here. We have to start counting 1 from the right side. So 1, 2, so it will be split out here. So and then when you are know, so this will be 10 to the power of because we gave it 2, this will be 100, and then this will be Ziga. This will end up being 42 divided by 100. This will return, of course, like this will be 42.42, but since we're doing integer division, it will get floored, because yeah, we don't have any floating like point. We don't have any, yeah, we're not gonna store a floating point value, so it's just gonna be 42. So first is gonna, in this case, it's gonna be 42. So how do we get, so after we get 42, how do we get the rest of it? So we can, I guess, to get the second part, or what's left over, we can get that by taking 42, which is the original number or the ID, and then we can subtract the first, which is 42, times the power we calculated, which is 100. So this will end up being 4200 or 4200. ከዛ በኋላ ይቀነስ, it will give us 42, so it will be the second part. This will work the same if it's not even repeating 433 and stuff like that, but yeah, so this is how that happens. But there is a case here, for example, if we just do 2 and then we give it 2, or something more than 2, if it was like 10, if you give it to something like this will end up being ይሄንኛው እዚህ ጋር 2 ሲካፈል 10 ይሆናል, which is gonna be 0, and then it's gonna be እዚህ ጋር 2 ሲቀነስ 0 ይሆናል. So this means we didn't actually separate the number. So if the first number is 0 and then the second number is equal to the ID, which means we didn't subtract anything to it, that's because we didn't split anything, so we're just gonna return none. So that's why I made this optional. And it will also, so how are we using this number? We're using it to create this digit chunks function. I don't want to spend a lot of time on this, but it's because it's tomorrow's it's yesterday's solution. But yeah, I'm just gonna talk about this a little bit. So in here, what we're doing is we get the digits, we get how many digits the number we are given has, because like I said, the odd number here starts counting from the right, not the left, so we can't just keep on incrementing it. We have to do like digits, the length subtracted by the current size or the current position we want to split it at. So if we wanted to split it at 2, if the number had like 5 digits, that would actually end up being 3, the third position. So because we're counting from the right side, not the left side, so that's why we needed to do this. And then we call splitting with that given odd value we just calculated. And then if we find something, if it indeed did split it to like 2 chunks, we're gonna call the digit chunks in our function, because we're doing recursion, and then we're gonna give it the second one, because now we want to keep the sliding window going and then split the second one, and then we'll give it the same size or the same like point of the because it doesn't change where you split it. If you're splitting it at the second position, you're always going to be splitting it at the second position as you chunk along, because that doesn't change. And then we add the number we just calculated, or the first part of the number we just chunked out into our previous list of numbers. So, and then I think someone was confused about why we needed to add a reverse. Yeah, so the reverse is just an, an anomaly of like me doing this in a functional language. So what we do in functional languages is our lists are uh, almost always linked lists. So it's easier to add a list to the first element than just to append it at the end here, because to append it we would have to iterate over. It's a linked list basically, so we'd have to iterate over each node and add it, find the pointer to the last one and add it there. So what we do is we just keep on consing it. This operation is called consing. So you just add it to the first, you just add it as the first element of the list, and then finally when you get your final nums array, because once the splitting ends, this will be this the numbers in here will be reversed. So because because we are adding our stuff to the first element, we are basically prepending our stuff to the array. So that's why we needed to do a reverse. And then I just have this inner wrapper function, because here so this nums array is just it's just some state that's being used for the recursion, not actually part of the definition of the function. So I just have a wrapper. So basically, if you've ever programmed in a functional language, you basically see this inner and then function name and then function name inner pattern a whole lot, especially when, and then this function I basically optimize all my recursions to be tail call optimizable. So, and then we could have done like something like this. We could have done something like this, but I don't like doing that. If we could have done like something like this, we could just add the first one, and then we say spread the rest of the main. Something like this, but I don't like doing this. This is not like tail call optimizable, which is another concept which will not go over today. So basically, and then so the is valid function barely changed. We just so instead of segmenting the string, we now segment the integer itself, and then we calculate that, we get the first value, and then we check that all of them are equal. And then basically one special thing we have to do is for some situations where this was detecting stuff like this, because for if you give this an is invalid, and then give it like 10 no 10 not 10 10 something like this 10 0 1. If you give it something like this, basically the integer splitting, when you ask it to split it, for example, when you ask it to split int at the second position, this will return to you 10 comma 1, I think. Or if you, yeah, so this will end up, this is what will be happening, because we can't do like 0 1, because if it's an integer we don't have any prefix zeros or anything like that. But if you give it, if you make this 1, all the intermediate zeros, I don't know, were they part of the API? But for some cases, basically we needed to, so there were like some cases where there were zeros in the middle of the integer, so we would lose some digits during the segmentation. So, and then those were causing some problems. So I came up with this. So basically the solution for that was basically define our expected segment count, because if it's going to be an invalid number, it should follow a clear pattern. It should be like two-sized arrays, or three-sized arrays, or three one-sized arrays, or something like that. So since we always know that the final count of the list should be, which is id digits divided by the chunk size, and then we're using a ceiling divider, because which means we just divide it and seal the value. And then I had to just create a function for that. Ignore that doesn't really matter. And then so yeah, so basically, oh, we spent 18 minutes on this, but basically, so yeah, we just calculate the correct lengths, and then we make sure that all are equal, and then we have the correct lengths, and then yeah, so let me just yeah, so if we run this gleam run, oh no, day 2 part 2 gleam run, I'm basically logging the numbers, but if we go in here and do int.sum, we will be able to see. So this was the example results for the second part, and yeah, so this is the result, and then it basically works for my input too. So yeah, but let's forget about that and start the reading the today's today's puzzle. But today I'm actually not sure. I'm thinking of doing it in I didn't decide. I should have decided yesterday what I would be using. Now I'm gonna call this fix some nums in the O2 part O2. This is working. Okay. And then the recording is going. Yep. Okay. Okay. So let's push this. I had two languages I wanted to use today. The first one is Idris 2 specifically. Let me just have you still correct, right? Yeah, so the first one is Idris, but this is also another functional programming language. And I think I've used it before, but I don't remember it that well. I've used it once. If we go to Fractals and then repositories and then Idris, yeah, I think I made this Hazarda project and another project with it. Maybe let's look at this. Basically, I talked about the Hazarda project yesterday. So it's just basically a random number generator game that I implement whenever I'm interested in a new language. I like these where chains. I like how this looks. I like how this looks. Maybe we should do it. We should do it with Idris. But the other one I was considering was doing for today was Zig. But like every single time I want to try out Zig, I just so if I did I push it to GitHub or GitHub? Fractals, Zig, links. Did I push it? No, I didn't. I remember doing the Zig links exercises like a year ago or something like that. Do I have Zig in here somewhere? I guess I didn't push it to GitHub, but yeah. So Rust has this Rust links project that basically meant to these are like small exercises meant to teach you Rust, and then in the Zig wallet they have Zig links, which is basically the same thing but for Zig. Yeah, and then okay, this has also to Kohlberg, but yeah. So but like I like my types. I like enums. I like my not enums with just that just compile down to an int. I like my algebraic data types. That's what I want to say. My product types, my sum types. So even though I think the language is cool, I need more types. Come on, give me more types. So maybe we can do this to tomorrow, but I'm not sure. So, but just let's read the program, the puzzle for today. Also, basically, by the way, paid for Advent of Code. No, not paid for, but just donated because yeah, just yeah, yeah. You just send okay. Dicery lobby. You just send a lobby staircase entire. The surprisingly vast lobby and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They are all offline. No, no, okay. Okay, they are all offline. Sorry about that. Anilf apologizes. As cheating cars with a nearby control panel, some kind of electrical surge seems to have fried them. I will try to get them online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the printing department. Not that you would get much further than that without the elevators working. That is, you could if the escalators weren't offline. Okay, but don't worry, it's not fried. It just needs power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their voltage voltage ratings. Why did they highlight this? Is it an actual thing? No, it refers to a similar puzzle from the past, back in 2020. Okay, rating a value from 1 to 9. You make a note of their voltage ratings, your paddle input, for example, ba 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 bam, ba 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 bam. The batteries are arranged into banks. Each line of digit in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly two batteries. The voltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. Okay, let me read that again. Each line of digits in your input correspond to a single bank of batteries. So one line it's called a bank of batteries. Within each bank, you need to turn on exactly two batteries. So okay, each one of them needs to be okay. The voltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. For example, if you have a bank like 1, 2, 3, 4, 5, and you turn on batteries 2 and 4, the bank would produce 24 joules. You cannot rearrange the batteries. I guess so. We're summing it up. Is that what's happening? Yeah, so that's 6, 10, 15. But turn on. I guess, okay, 2, 4, okay. Uh, is that what I mean? You turn on the batteries 2 and 4. So we're just concatenating them, and those end up being the digits of our new number. You will need to find the largest possible voltage each bank can produce. In the above example, 9, 8, you can make the largest voltage possible, 9, 8, by turning on the first two batteries. Okay. Okay, that makes sense. You can make the largest possible voltage possible turning on the batteries 8, 9, and then for this it's 7, 8, and then for this it's 9, 2. So we have to iterate over the digits of each bank, I guess, and then we can do. I hope they have permutations or combinations, like kind of library, or no, and then we can reduce by max. Uh, yeah, I think this should be easy. This should be easy. The total output voltage is the sum of the maximum voltage from each bank. There are many batteries in front of you. Find the maximum voltage possible for each bank. What is the total output voltage? Yeah, I don't know. I think this should be a simple enough thing to do with Zig. And another thing I'm considering why I don't really want to go with Idris is because my editor Helix doesn't syntax highlight it. Does GitHub syntax highlight it? I don't think so. Oh, GitHub syntax highlights it, but Helix doesn't for some reason. If we do Helix has so three-seater parser, there is a three-seater highlight queries, nope. Text object queries, nope. Indent queries, but it needs the Idris LSP. So what should we use? Should we use Zig or should we use Idris? For string. Yeah, they don't even have splits. I'm gonna be indexing bytes, and stuff. And then let's go back to, I guess, let's look at the Flake.nix for this one. What did we need to do to install Idris? So it's just gonna be Idris 2. Flake.nix. And then let's install Idris 2. I don't even remember how to compile stuff in this language. Maybe you can. So it's Idris -- build. Okay, let's wait for that to install. And then let's create day 3. In day 3 we need to create our inputs. In inputs we need to create our example. Let's come here, copy this over, and then close that, and then touch basically let's check for how's Idris. Oh, Idris 2a-lsp is not found, which must be another package. Let's go back to Flake.nix and see if there is something called packages.idris2-lsp. We're going to be going back to the basics. We're gonna be coding with no syntax highlighting, just plain old code and a terminal. Let's go to here, Idris LSP. Do they have it? No, it's part of Idris itself. Of course, that's expected. Flake.nix. At least we'll have an LSP. I don't know what that would look like, but it's gonna look weird. Having an LSP but no syntax highlighting is weird. Like this, I guess. Yep. And then let's save that. Wait for it to install. Maybe we'll do Zig tomorrow, I guess. Yeah, I think Zig is gonna be the language we're going to be using for tomorrow. But today I want to use Idris. We'll use this as a reference because I think in one of them, I think in the LC3 disassembler, I think in here I read a file, so I forgot how to do that, so we're gonna be referring to this on how to read a file. I think actually I built this project in a live stream, if I remember correctly. It was a live stream on the Devtopia channel. I think if you go to the live stream tab on the Devtopia channel, I think there is a stream of me building this LC3 Idris disassembler. And then let's check on the health again. So now it knows where it is. And then let's go into day. We're already in day 3. So let's create a file called touch. Okay, part1.idr. And then let's create a. And then let's do Idris 2-build part1.idr, which is gonna fail because it expects a module definition. Oh, we need to do. I thought we don't need to do that. Okay. Wait a minute. We need to initialize a project. And then let's go back here. Oh yeah, we're calling it on the okay. So it's gonna end up being the same pattern as yesterday. So Idris 2 -help. Is there an init or something like that in here? Yeah, okay, dash dash init Idris2 dash dash init, and then the package name is going to be part1. Package authors is going to be, let's say, breakdown. I don't know, I don't care about source directory, just decide it. Okay, it just created it on the same on the same directory. I don't care about the part2. And then let's look at part1 IDR. It's basically empty. No, that part1, no, part1 dot package, which is, this is the like the package.json of the Idris world. So yeah, we need to define main executable and stuff like that in here. So they've already defined the package, which is part1, all version, which we don't care about, authors, and then these are all commented out, and then main, we don't have a main here, we need to define a main, and then executable, and then source there. Okay, we didn't need to specify a source there. Come on. Okay, so I think we're gonna have to create something like this. Make their part dash one, part1, and then go into here, initialize it. Let's call this part1. Let's call this return options. Source directory is gonna be source. And then let's go into here, and then source directory is source there, and then main. Let's comment this out. This is gonna be part1. Just what we have here, main, and then we don't need anything else. Yep. Yeah. Okay. So in here we need to create a source directory, and then in the source directory we need to create a part1.idr, and then in that part1.idr we need to say module, or no, we don't need to do, we need to say module part1, because I think that's what we did here. We need to tell it what module it is. Yeah, and then go back, list all.ipackage. Yes. Then part1.idr, also remove that, and then move inputs to part1. Oh, it already created a build directory because the LSP run. That's why it created the build directory. But so this is gonna be our file, and then this is gonna be our compiler, and then I think it should complain saying something about it didn't find the main function. I think that's what I expect to happen. Idris dash build dash part1.ipackage. Oh, it didn't complain. Okay, so let's define our main function and maybe print something. This is gonna be a main function, and hopefully they just have something like print. It's part of the prelude, so it must be there. So it's print ln hello address. Okay, it's weird because the LSP is there, the file is being formatted, but we don't have a syntax file, I think. And then okay, we just built it, so we have to run it. And how do we run it? I think we have to run something from from the build directory. So it's build exec, so it's build exec OTTC. What? Now compiling the executable LD3. Okay. Oh, we didn't tell it what the executable. So iPackage executable. We told it what the main was, but we need to also tell it which one is the executable we want, which are, yeah, so what's the name of the executable. So we want to generate one executable, and that should be named part1, I think. So that should, yeah, okay. So build exec part1. Oh, hello Idris. Okay, so that got printed. So we've set it up, and then that took us 40 minutes. And then we need to set up a git ignore here, which is gonna ignore build. And then what else? Oh, git, if I can spell that correctly. Git ignore, and then build, and then save. And then, okay. So I'm just gonna commit char setup address. Okay, so we need to, of course, like we did yesterday, we need to create a type. But today's type are, I don't think are gonna be complex as the ones we are doing in the past couple of days. This is basically going to be how do we, let's go to the Idris docs. How do I create a type alias? Type alias, or just the alias. But they don't know about that. They don't know about type aliases, but maybe somewhere around here. So to define a type, you call the keyword data, and then the data space is how you define types. But let's look for the type docs, I guess. Or maybe we can just say a crash course in Idris too. Yeah, and then getting started, types and functions. Okay, this is how I define a type. Address to type alias. Oh, okay, so this is only used for functions. Okay, I guess ignore that, and then I guess we're not gonna iterate. We're not gonna create any types. But the first thing we need to do is create a function that's called parseBank, which is basically gonna take in a string. I think they call theirs. Yeah, so they just call it a string. So, and then it will return at least. So a list of ints, right? Yeah. So, and then this will be defined as parseBank. ParseBank. Str is equals to string dot split, or do they have a split? First of all, string. Oh, there's only two things it's showing me, that I can do concatenation and that I can get the length of a string. Um, Standard library or reference guide. String literals in. Let's look for split. Interpolation. This is how you do interpolation. Foreign function interface. Where to find libraries. Maybe let's go back to the crash course and okay, so Idris string. Yeah, so data string. Okay, this is what we want. Yep. So do they have a split? Okay, do they have a words? Do they have splits? Oh, they have lines. Beautiful. Okay, they have lines. They have span. They have break. This is what I think. This is what we want. Break splits the. Oh, what we want is actually cars. We don't want to. We don't want to. We don't want to split anything. It's just give me the list of cars. Right. So lines is actually does something that we want. It splits a character list into a list of new line separated character lists. So this is exactly the pattern we have for our banks. Right. So this should work. Yeah, let's do this. Let's use this lines function. So that will change how this thing works. So this should go from a list of car into a list of into a list of int, and then let's go look at the definitions for car. I remember there was a searchable Idris to searchable reference or docs. Somebody had forked it, and then that's what I was using to it had a search bar at the left side of it. Car string is there, but car is not there. Maybe they link to it. No, they don't. We gotta use Google today. Idris car documentation. Character. Yeah, I also remember doing this. Yeah, we have to look at the implementation of string, I guess. String.idr and go find car. Or let's just search the code for car. Where is car defined? Char, I guess. Char, that's what I thought. So this is where it's defined. I thought it would be something like data char. We just need to know how to convert that char into a number. Let's look for char in here. Yeah, and then so they have it. Span break. It is a built-in type to the compiler, but I don't know why we don't have any function for it. Docs for it, I guess. Let's do that. And then maybe we can modify maybe this should be where char is. Nope. 8 raised to maybe it's part of the prelude char, or it's part of basics. Char. Or let's look at the types for they have a different kind of, I think they have nuts here. Yeah, they have not a nut or a natural number. So let's go find Idris nut, and then maybe there is a function in here to convert a car into a nut, or a char into a nut. Come on, just searching for APIs is gonna be crazy. I think they also have an int address, int. But they call them integers, okay. I guess we can duplicate this and then do integer here. No, it's not that. Integer. I guess we gotta consult the Oracle. I'm gonna go to how to convert a char into a nut in address 2. Last time I was trying it, I think I remember that ChatGPT was confused that it thought we were using Haskell. It says we can use this function. Basically, it's basically saying that there is a char to nut or an OR function that will give us an int, and then we convert it to a natural nut using cast. So if we say something like, I think that's what your example said, char to nut, and say 1, and then it is compile. So it says 49. That's not what we want. That's not what we want. I want to parse and a car to an int. Oh my god! What? Oh shit! It's like stupid. Where am I doing? Where am I doing car? So this should just be something like this. What am I even doing? Should just be, I'm just gonna, we're in the functional world now, so let's just do this. Let's just do this again and again. Let's do this for each integer, I don't care. And then this would be 1, this would be 2, this would be 3, and then 4, and then 5, and then 6, and then 7. We're gonna have to do some dumb stuff like this because the API, the libraries, it's not gonna cooperate with us. And then 0, and no, not 0, 9, 8, 7, 6, 5, 4, 3, 2, and 1, and 0. and then in the base case we're gonna have to do ignore that and say nothing. I think that's how we do it, and then we have to say it's a maybe, it's a maybe not, and then we have to prepend all of this. Nope. With a just, right? And then here, if we compile it and run it again, just one. What was I spending all that time for? Just, we don't even need the oracle for this. Just shut up. Okay, I think we have our car2not function, and basically in here what we need to do is list.map, and then map maybe, yeah, that's what we need. So list.filter map, I guess that's map maybe, and then call car2not the autocomplete is borked. I just car2not. Okay, while proceeding right hand, oh, this is gonna be a list not, I guess, but it's still complaining. So oh, okay, this is cars, and then maybe we need to pass in cars here. Is it that what it's saying? Yeah. Okay, so we have our parseBank function, and then we're gonna say what is the whole thing called? Let's call it our just parse input function, and then the parse input function is gonna take in a string, and then it's gonna return a list of not, right? So we can do parse input is takes in a star, and then string dot lines with a backtick, and then give it the star, right? And then we need to pipe that into list dot map, and then parse bank. This is what I expect to be able to do, but it's saying undefined name dot lines backtick, lines backtick, lions. Okay, there it is. There's the function. There is the function we wanted. Split a character into a list of new line separated character. Okay. We need to say maybe data dot string lines. What if we is this part of the API? I think we need to do some kind of import data dot string, or maybe, yeah, I think we need to import it so that it knows about it. No, okay, now it knows about it. Okay, so, and then we can come here and do other backtick hopefully, and then we can say this. Oh, okay, lines expects a list of car. but there is no way for us to get a list of car, right? Oh, it's using something called unpack here to unpack them. Where is unpack? I see that it's being used a couple of places, but I guess we can use it too. So this is gonna be unpack the star, and then pipe it into lines, and then okay. Now I guess the error has shifted to somewhere else. Did you mean map? I think we also need to import list for this, or maybe have I used map in here? Where was this? Nope. List. Let's close this, and then duplicate this, and then close that, and then maybe we can find the list. Do I do this? Okay. Yep, there it is. Map. Links map, maybe, map fusion, map append. Is there not a normal map? Maybe it's telling me to just use map, so I can just say .map. Oh, it turns out it was correct. Trust the compiler. Build exec and then part one, which is what we just so this is what we'll see. So let's read the file, right? So I don't remember how to read a file in address. I did that here though, somewhere around here. Read file or IO read array. Okay. This is gonna be annoying. Where exactly do I read the file? So we gotta work with file handles and stuff like that. Not seeing the read function yet. So here it is. We have a read image, and then you have to create a buffer and stuff like that. Oh shit, this is gonna be horrible. Let's ask the oracle again. Read file in address 2. Okay, there is just a read file thing. Then let's hopefully print out the contents. And no, there is no such thing as an address read file. Oh, it's from system. And then import system address. I don't have anything called read file address to read file. System.file, okay. System.file. Okay, I think. Okay, so I think we are able to read it. And then this should be read file inputs dot, because that's where our input is. And then let's do address to that, and then do that. Left file not found. Inputs example.txt. There it is. There is the file. What you're talking about. There is the file. And then let's run it again, I guess. Okay, here it is. Yeah, and then now we can pass this to parse input and see what we get, to see that if we're parsing correctly. Oh, this could fail, so this could fail. Um, I think if I remember correctly, we have to just do an exclamation mark in front of it so that it bubbles up. Is that what I'm thinking? Or something like this. While crossing the right hand side of main, when unifying so here we created the buffer, and then where the field memory. Execute command, parse command, execute command. Execute command, it takes in a command, read image, the file, which is this function, which I guess we can just we can just do the correct thing here and say either no, we can just say so the left value, the right value is the stuff we want. So write contents, or break into a new line, and then say left something, and then we can say print line, and then we can say failed to read input, right? Should make sense. And then we can remove that, then okay, this has to be fat arrow, and yeah, I think that's what we need to do. Nice. So our parser is working correctly, I think. So 987 let's go back here, 9 okay. So now let's go into the solution. We're 1 hour into it as usual. ሁሌም ከአንድ ሰዓት በኋላ ነው ወደ solution የምንሄደው. So okay, how do we calculate the solution here? So we have a list of knots. So what we need to do is iterate. So it's gonna be for each number we're gonna have to iterate over the whole list, or because we can't go back, we have to iterate over a subset of the list, because it said I think somewhere around here, yeah, basically we can't just march backwards. Like if we were at 6 and then we can't say, we can't like, so here it would be 89, but if we could go over from each number to the front, but we'd have to do 98 would be the largest number, but all of them will be marching towards or trying to get the largest number by concatenating with all numbers that are to the right of them. They don't consider anything to the left of them, or to the left of them. And I think maybe the smart way to do this would be just to sort the numbers, and then take the first two, right? I think I'm correct on that. Just sort the list of numbers and take the first two elements. That should work. Should always work. We have a list of digits, we have a list of ints, we have a list of single digit numbers. So if I just sort this from the max to the min, I'll get the first two. If I sort this, this will end up being 9 8. It won't be 8 9. So that won't work. Sorting won't work, because it could reorder the digits. yeah, I think we're gonna have to do the double loop. Okay, so this is gonna be find max combination in a list of not and then hopefully there is a combination library function here. Or we can create it ourselves, but yeah. Find max. We need something that should be able to take something like this, right? And then a list of two natural numbers concatenated together. Is there a zip in here? Zip hubble or take while lookup, delete that, delete by span partition. It needs there to split on intersect, but there are a lot of those. There are a lot of functions here, but maybe the one we want is just a different name. But so the plan is, yeah. So imagine if we were getting a list of like the combination, so 9. So for example, when we run this with 9, this will generate a list with 9, 8, 9, 7, 9, 6, 9, 5, 9, 4, 9, 3, 9, 2, 9, 1. And then we can do that for 8, 7, 8. But we'll be dropping the list, I think. So should be 8, 7, 8, 6. Oh no, yeah. So it doesn't care about the values to the left of it. So this will be 8, 7, 8, 6, 8, 5, 8, 4, and then this will be 7, 6, 7, 5. So, yeah. So okay. So and then this will return a single NOT, right? If I'm not mistaken. And then find max combination. Find map combination. List. And then we're gonna map over the list and say we need something like combine digits, which is gonna take a not comma not, and then return and then we can say combine digits is gonna take a x and a y, and then it's gonna return x or not to something like that, string. So what I'm trying to do is, I think we saw a docs here. Where to find compiling not that reference guide, in the reference guide maybe string literals, yeah. So here interpolated strings, just have to do a backtick. So this will be a backtick x and backtick y situation, but this is returning a string, I think. It's complaining. And then I guess this should be x comma y, and then here while processing the right hand side cannot find an implementation for interpolation of not. There must be some way to turn a not into a string, or a car, I guess. Car address to not to string. basically we're just trying to do the inverse of this. Maybe we just have to define it ourselves. I don't care. Oh, show. Okay, show. You can just say show, and then you can just say show. Yep. So this will be a string, and then we already have. So we need actually a real, a real version of that thing. We are running into the same problem again because we need to convert, or actually we don't need to convert this into a string. Why am I being stupid? So this should be x times 100 plus y, right? Why am I going down the string route? This is how you convert them. This is how you combine them. And then this would be the not 100, or I need to parenthesize that. Idris. Okay. I think let's do this then. 100 where 100 equals 100, and this will be a not like that. Can now find an implementation for not type. I think, yeah, so by default when you type in a number it will be so I think what you need to do is cast. So maybe here I need to do cast. When you just type in a literal or like a number, it's not gonna be a not, it's gonna be an int. But I think I remember doing something like this. You have to do the not and then 100, right? So and then you can do that, and then mismatch between not and. Okay. Oh no. Okay, this should be a not. Okay, yeah, so I was right about the not thing. So address and then save, and then maybe just comment this out so that it can format it. I thought it should format it, didn't. I guess we don't need this anymore. We can just say the not 100 address. Do they have a format command, by the way? Dash format, dash help, and then just no, I closed it accidentally. Address help, then search for format. Yep, they don't have a format. Okay, we don't need that, but basically let's run this again. So okay, combine digits is gonna do that because we're gonna be combining only 2 digits. This combine digits function should work correctly, and then what we need to do in here is uncomment this. So map, let's start with the list. We're gonna pipe that list into this map, and then that map is gonna call combine digits on each one of those tuples, right? And then this should of course appear before this because that depends on that. And then yeah, I think we're done. And then we need to, this is a list of nodes, so this would be, so we just need to do something like this. You need to find the maximum one. So I hope they have a list. How do we get the maximum one? maximum. There is a maximum, so we need to do max, or let's do here. Of course I don't have a max, so we need to do is we need to fold left or fold L. Yep, we have a fold L. Why there are one? Fold an empty list without sealing the accumulator. Without sealing the accumulator. What? No, with sealing the accumulator. How can you fold without sealing the accumulator? Fold. I don't know how you would fold without sealing the accumulator, but I think this is what we want. So, and then we would just do list dot, or we can do just something like this, list dot fold mail one, and then give it the not dot maximum function, and then it's gotta start with 0. So, and then just keep on accumulating, finding the highest one. So I think that's what I expect to work, but apparently they don't do that. That's not how they do things. Okay, so undefined. Okay, we need to import, I guess, import data dot not, maybe. While processing the right hand sign, find combination when unifying to do the mismatch between list not and not. Okay. Maybe let's do that. Cheers. Mismatch between, yeah, so I don't like this stuff. I don't like this stuff at all. I don't like it at all. So what we need to do is something else. We need to create our own fold. Don't tell me we have to create our own fold. Fold. They have a system of proofs and stuff, so we have to prove that this list is not empty. I don't want to deal with that. Come on. Yeah. I think what we need to do, maybe we need to create our own fold. I think that's what we're getting at. It's gonna be annoying, but we need to create our own fold. Or we can ask the oracle how to fold over a list in address. There might be just a fold function, just like there is a map function that's not part of. Yeah, I think, okay, nice, beautiful. So we don't need to use the function from list, we can just fold L. Yeah, and then we can call, and then of course this is like the normal fold we know and love, and then it will take the accumulator here. Nice, beautiful. Okay, so we have a way to find the max combination. So now what we need to do is create a combination. A combination of this. Yeah, so that's window sliding thing. How would we do that? So here we need to create a function called generate combinations. right? And then the generic combinations will take a list of nuts, and then it will return a list of not comma not, right? So we'll just iterate over the first list we got and just keep calling it again and again, keep on sliding that window, and finally return. Yeah, so just, yeah, I think that's what we need to do. Yeah, and then we can say generate combinations, takes a list, or I'm gonna call it an list, I guess, to not confuse the name with something else. And then what it's gonna do is until that list is empty, just keep on. So we need to define something here. We need to create a where clause. So because, and then in here we need to say we need something like something like this: combinations, and then given an x and an xs, right? So combinations x, no, this is a not followed by a list of not, and I'll give you, this is the first function we need, and then not, right? And then this will be defined as map anonymous. I don't know how you can create anonymous functions in this language, but figure it out. So let's just do the default. This is what I expect. So this would be, I guess this would be a y, and then this would be an x and y's, I guess, and then it will take the y's, and then it will return x comma y, right? It will iterate over the y's we gave it and generate the combinations for that. And then we need these combinations in where, so let's call this generate combinations inner, and then it will take a list of not, like we said, but it will also have an accumulator of the list, the double list stuff, not, right? And then so this one would be recursive, generate combinations. I don't like actually doing inner, and instead I like doing a backtick. So backtick, and then access, and then result, right? And then this should be duplicated twice. We're accumulating the results. And then here we need to do case or pattern matching. How do you pattern match? Tell me how you pattern match. Redux. How do you do a pattern match? Get started, maybe. Okay, next. Now the where clause lets us chain multiple definitions, nest multiple definitions within for a single thing, and type holds, does not even care about that. First class types, vectors, the finite sets, don't care about that. Now there is a section on IO, do iterations, laziness, infinite. pattern matching in address. What's the keyword? Is it a cases or a match situation? I guess okay, the pattern matching needs to be okay. Okay, so it's gotta be something like this. So generate combinations is this type. So we already told it that type. So in the case of this being an empty string, we should, this is the base case because we've finished slicing out all of everything from the first from the first, and then we would need to do something like reverse. I'm not sure. Yeah, hopefully they have a reverse here somewhere. No, I think these don't need to be dependent on each other. So here we would call generate combinations inner, and then with the list, and then an empty list. The result will be empty first. So expected pop up, and then here I'm missing case. Yep, beautiful, thank you. And then we can say head followed by the tail, right? No. Or this needs to be parenthesized. Yep. And then here what we need to do is we need to call generate combinations. Of course, we need to call ourselves. It's a recursive function, generate combinations with a backtick, and then we need to give it the tail because now we've removed the head, and then the result will be combinations of head to the tail, right? We've taken over the head, and then we're gonna combine it to the tail, and then that const on the result. Just append that to the result. That's what we're telling it to do. Prepend that to the result. Yep. Okay. While processing, okay, it's complaining about the use of combinations. While processing right hand side of generate combinations, while processing right hand side, undefined name combinations as a combinations, right? Just have to spell the number correctly. Did you mean generate combinations? I thought that means if I had defined it in Isn't this how it works? Or maybe something like this? I don't know. And then this will be, should nest the where under here, and then just do that. Something like that. This is how you do it. It's not recognizing generate combinations. I don't know why that is. Did I? Oh, of course I misspelled it. Come on. Combinations. Yep. Okay. Idris. Okay. So I think this is how you find. So okay. So now let's compose our functions and get the result. So find max. Oh, so find. What are we finding actually? I forgot. What is this? Okay, so okay, so find max voltage for find max in bank, I guess. Find max voltage in bank. We're gonna receive, we're gonna the bank, which is a list of nuts, and then we're gonna return a single nut, which is the maximum one. Find max, and then this will be bank equals, so we're gonna generate the combinations. Generate the combinations for the given bank, and then we're gonna pipe that into find max combination, right? And then save that, and then let's do this. Find max combination is already defined. Oh, okay, this should be find max voltage. Trace. This returns a list of nuts. Oh, and then for each one of them we need to do this, right? For each combination we need to find the maximum one, and then from all the max, so I think that's how we do it, right? And then we have to pipe this into fold L not dot maximum maximum 0. Yep, I think this is it. And then let's break this down into multiple lines so that it's readable. So map that, and then find the maximum of all the combinations, right? So this is what we'll get for each so let's just do this, parse contents and find the max combination, and then map each one with this, and then wrap this with a show, or we can pipe this into a show. Find max voltage in bank. Yep, okay, now let's run this and then build it. No, run that. Okay, so it's saying these are the maximum combinations. Oh, I know what's going wrong. The the one of the functions, so this combined digits should be 10 multiplied by 10, not multiplied by 100. So if we run this again, so the first maximum was 98, the second one was 89, the third one is 78, the fourth one is 92. Okay, and then we just have to sum this, right? So I guess that's sum, and then pipe. It's 357. Okay, I think we're ready now. Let's get our input. But I want to do this. I want to do find solution. Is gonna be this, which is gonna take a string, and then it will return one number. It's pow. Then find solution content the contents pipe that into parse input, and then that into a map, then pipe that into a thumb, then but it's like isn't this beautiful? Isn't this beautiful? I don't know, it's crazy. I don't know, it's like functional programming is beautiful, extremely beautiful. It's like clearly, just look at this. If it was an imperative language, this would be like 4 nested for loops or something like that, but here it's just, yeah, it's beautiful. Okay, so and then here what we just need to do is find solution, contents, and then print ln address. It's beautiful. Okay, so 357. Beautiful. Tell you it's beautiful. Okay, so let's get our input. Ooh, that's gonna be a big one. Okay, save. And then it's gonna be to workspace. It's gonna be, I don't know if it's gonna work. Replace. Yeah, that's a lot of numbers. Okay. Copy. I guess move. Input.text into the current inputs directory. Inputs. And then let's look at inputs. Yep, that's beautiful. Yes. So it's gotta be inputs.input.text, right? So, we have our input right there. Let's run this. Let's build it. I don't know, I think we need to build it, but yeah, let's run this. Okay, it said 17,179, so let's paste that in. Hey, we got 1 gold star. It took us how much time? It took us 2 hours or more, I think. Oh, 1 hour and 37. So we still have a chance. እስከ ዛሬ ከሁለት ሰዓት በላይ ቆይተን አናውቅም። So we still have a chance to complete it in under 2 hours. So implement day 3 part 1. No, I got that wrong. Come on. Oh, third try. Okay, we got it done. So try. Okay, push. Okay, let's go out and close this, and then what we need to do is copy PR part 1 to part 2, and then we're gonna go into part let's go back, part 2, and then we gotta rename some stuff, part 2, and then this should be move part 1, part 2, going to the part 2, and then should be part 2, and then part 2, and then part 2. Let's save that. Move source part 1, source part 2, source part 2, part 2, and then what else? I think and remove build somehow, and then let's go into parts 2, and then address /build, and then let's replace this with part 2. Yep, and then let's go into part 2. Let's go down there, and let's build it exec part 2. Okay, now it's running correctly. We can start working on the stream is working correctly, right? Okay, so we can start working on part 2 now. Let's go read it. Hopefully the twist won't be too impossible. Okay, the escalator doesn't move. The elf explains that it probably needs more joltage to overcome the static friction of the system and hits the big red jolt limit safety override button. You lose count of the number of times she needs to confirm. Yes, I'm sure, and decorate the lobby a bit while you wait. Now you need to make the largest voltage by turning on exactly 12 batteries within each bank. The voltage output for the bank is still the number formed by the digits of the batteries you've turned on. The only difference is now there will be 12 digits in each bank's voltage output instead of 2. So okay, that's gonna be the largest voltage that can be found by turning on everything except some ones at the end to produce in the digit sequence. The largest voltage can be found by turning on everything except some ones. So this is okay. So we now are looking for the largest possible 12 digit number, right? Yeah. Yeah, I think this is workable, but I don't know if for example, we need to create a tuple with 12 digits, or and then no, this doesn't make sense. We have to rework this mechanism. So our generic combinations function here is just gonna try to it's gonna be 12. It's gonna be like it's gonna be too it's gonna take too much time. Right, it's not gonna be correct. So we need to create like a combination here that just doesn't, so that won't work, right? How would it work? Instead of taking the matching to the rest of them, how would that work? We need to take the first one and then take the, not just take the match it with the first one, but no, that won't work. So we have to do something like, right? So how do we make the combinations work for 12 digits that need to be combined? This is gonna be like, so this is gonna be like a number like this, not 12 times. It's not gonna work. It's not gonna work. It's not gonna work like that. We need to rework our whole system. I think so. We need to rework the whole thing. Yeah, fuck. So instead what we should be doing is, but I don't know, because it can't be just a regular like slice. It's just like split it at this point, because for some of them you need to skip a number, like you need to skip 2 here, and then you need to skip like 1 here, so it can't be like a slice. So actually the general combinations does make sense, but we just have to combine or sum it up early. That's what I'm trying to say, right? So if we sum it up early, we can just return a NOT here, right? So it would already be combined. And then we can sort it. So we can already instead of keeping track of all the numbers, we can just keep track of the sum, because at the end of the day, Oh, we need to keep track of which numbers it is, right? Because that's the number we're going to. We can't just like 9 plus 8 plus 7 equal anchelo. Yeah, so combine it into 9 sequences. Maybe I need to write this down. So let me just use a pencil now. Let me just think through it. So if we have a so if we have a list of, so for example, let's look at this one, I guess. So if we started at 8 and then just try to combine it to the rest of the list, what we should be doing is it doesn't make sense. Combinations, and I guess let's do address, or let's ask ChatGPT or something. I guess I'm gonna ask it to write a combination function for a list. Yeah, choose k from a list. So instead we need to change this k to be okay. So I think I'm getting a hang of it. So instead of that, this should be a list of. So instead of a tuple, we're gonna need to use a list of nuts, and then here it would be x's, right? So, and then for each x, we need to go over. Yeah, for each. I think that's the first thing we need to change. So x's. So this is gonna be, so if we give it a list of 4 digits, let's say 4 to 1. We gave it a list of 9, 7,4. It just needs to go over each number and multiply them by 0, 1, 2. Multiply them by 9 times 10 to the power of their position in the list, I guess, plus 1. X times 10 to the power of their position in the list plus 1. So, and then finally we sum them up. So this should be map I. So I have a map I. They don't have a map I. So do they have a fold L M a fold L? So we're gonna need to use a fold to keep track of their position in the list, and then of course to sum it up as well. And then the fold is gonna take a single x, and I guess the fold takes 2 parameters actually, an x and a y, I guess. This is how we would do it. And then I can say x plus y, and then do 0. If that works. Let's check out the error though. think maybe this needs to be a space, I'm not sure. Yeah, okay, it needs to be a space. Okay, so instead of doing that, this would be the, which one is the accumulator? The second one is the accumulator. So accumulator, oh, I thought it worked. Oh, I thought it worked, it didn't work. What do we do that slash? I don't know how anonymous functions would look like, what anonymous functions look like. Let's just do anonymous functions in address. No, come on. Okay, so yeah, like I said, it should be access piped into this fold, and then it's a 0, that's an address build. Okay, it seems correct. And then here in the fold, I guess most commonly the first one is going to be the accumulator, and then the accumulator is actually our index, right? So it starts at 0, and then, or no, it's not going to be our index. We need an index, come on, we need an index. I guess we're gonna have two accumulators then. We're gonna have two accumulators because we're also gonna need to keep track of the, I guess we can do two folds, yeah, let's do two folds. So in this one we're just gonna say your index is your y, your index is index plus 1 and you are y, or in this case it would be, also we don't have to do the plus 1 then, so it will start at 1, and then no, we are iterating from the left to the right, so this should be a fold right, and then yeah, so and then we can use this, and then we can use this. So we can generalize. No, should we? No, it's not generalize. Let's not generalize that. Okay, so and then here we can say map, and then we can say take your index, and then view, and then return. What did we do? We said we said x times 10 to the power of your index, and then sum that address. So yeah, power, I don't know how to, what's the power, is this like this? Okay, let's say that not so that still not liking it. So let's just break this down into multiple lines. Just break it down, then dot, and then finally sum that up. And then that should be indented. Okay, So it's complaining that it doesn't know the types, cannot infer type for case scrutiny. But we just told you what type it is. It's just maybe we have to do the not zero here as well. Trace. While processing data, unifying not type, and then we also need to do the not maybe here. Every single time we have every single place where we have an accumulator somewhere, we can extract this out into a separate function. It will make it happy if it will make it happy. So we can call that add indexes, and then it will just take a natural number followed by another natural number, and then it will return a natural number comma natural number. Okay, I know what's going wrong here. What's going wrong here? So here we should be, it should be something like this then, right? So if we're gonna, so the return for the what gets returned from the accumulator is what gets returned from the what gets returned from the folder, right? So if that's the case, we can do instead of doing that, this should be something like, what should this be like? Should be like something like, I don't know how to do this. How is there not a map index? Fuck. Address map with index. Oh, my light just went out, but hopefully I have enough charge to complete this. I think maybe I'm just gonna use this, I guess. I'm just gonna use that. We tried to create our own map function, but yeah, we were not successful. So here we should do, instead of saying dot, we can just say dot, and then we can say map with index. And then we still have the index and then the x, but now they're, oh nice, beautiful. Okay, now it's working, I think. But it's complaining about, oh, we're missing a comma there, and then address build, and then it's complaining about that, what it is, and then address, I guess it's integer power in address. Oh, by the way, this successor thing is because, yeah, we can just say I+1 if we wanted to. It will have the same effect, but yeah, the successor one is, yeah, it's using, what are they called? Those number. Well, I think some guy. Some some guy from the early days of functional programming. It's like during the times of Turing and stuff, there was another form of computing called lambda calculus. So this successor and then giving it the number stuff is from that stuff. So I don't actually care about that much, but yeah, it's from that. So there's a we tried to use that earlier. It told us that's an error. Then do that. It said unknown operator. Is there a POW? Is there a POW? If there's a POW. So this should be 10. Nice. Okay. I think this should be it, right? Yep, I'm doing that. Yeah, I'm gonna, because በአሁኑ አመት ወደ ያው ቀንሰውታል በጣም ድሮ 24 25 የነበረውን 12 ስላደረጉት I think we can go all the way. I think we can go all the way. But yeah. So that's how we're gonna combine the digits, and then now we have to change our types to be, this should be a list of not, like a list of natural numbers, and then it will call combine digits on them. Let me just run this and see what the error is. Maybe we need to parenthesize. I don't know what's complaining about. Oh, but it should be a list of nuts. Okay, I guess. Yeah. Instead of a list of being a tuple, it's now a list of list. Okay. And then so this function should be the same. We just need to create a smarter generate combinations function here. So find max. Yeah. So we just need to update this to return a list of natural values, natural numbers. Oh, that we're 3 levels down. Okay. And then we need to modify this, but I wish they had a combinations library in their standard library, but Idris, maybe they have a permutations. If they have a permutations, they must have some kind of permute. If they have a permute, okay, what's the result? We gave it ABCD and then it returned ADCB. And then this is, I guess, the permutation to apply. Okay, that's not what we want. Oh, there is a library for it. Oh no, I don't think we're gonna install a library, but provide a type safe way of working with permutations in Idris. Idris combinations. Think. So let's think about this. I guess let's think about this more clearly. So instead of combining 2 numbers, what we need to do is keep on just add all of the y's, I guess. Or this needs to be called 12 times or n times, where n is the length of y's. Combinations. I guess. No, it's not. We don't want the count of the combinations, but for a list. Yes, using a built-in thing from eTurtles here. So we want, yeah. I don't know. I'm kind of. I don't know. I think. Should we? I think we need to create this. We need to create this because it's an independent thing. It's, yeah. It's. I think we have it here, but like, let's work on this. I guess this should be a list. This should return a list of not. Let's think of this like step by step. So first, it's gonna take a combination, and then the thing to combine is going to be, it's gonna be the, we're still gonna need so we need a list first, right? We need an input list and then a number to signify how many times we should group it. So in our case this would be 12, but I just want it to be general, and then it will return a list of nuts, natural numbers. So because we're asking this function, I want you to give me all the unique 12 combinations of all the elements, like I want you to give me all the lists of all the possible 12 digit, or I guess 12, all the possible lists that have the length 12, that could be generated by combining unique elements of this list. I think that's what basically I think. So this is gonna be multiple lists. Yeah, it's gonna be multiple lists because, yeah, get combinations will be multiple of them. We're creating multiple lists, and then so for the first case, this will be empty when it's an empty list because we're done. And then I guess this should be 0 in that case, and then we can return the empty string, empty list, and then otherwise we can say combinations. I remember like a while ago, something GitHub Fractals Advent, no, Elm, something was Elm. Let's look for Elm. I think if we 99 Elm problem. So there was a combinations implementation in here, if I remember correctly. Combinations. There is a permutation implementation. Yes. Permutations. Nope, I don't think we have it. I thought I had implemented it, but now we don't. Okay, let's go back. So okay, so when we should have an empty list and a 0, and then so for the other case we take out the head and then we leave out the tail, and then this will be some x, and then we can call head because head prepended by the combinations of, I guess this should be something like the tail, and then x minus 1. Is this how is this what it would be? This what it would be? I don't know. So but where's the other list though? Oh no, this is getting too complex. I don't think I can do it. I don't think I can do it. Let's look for another, like combinations, like implemented in another language. Combinations implementation in Haskell, for example. Okay, let's look at this. So if the first, okay, so this should be something like this, I guess. Our order is slightly different than theirs, but so this would be a list, a single list as an empty value, but we don't care about the size of the. And then if we have a number and then base case choosing 0 elements always returns in a list containing an empty list. Okay, base cannot choose elements from an empty list. Okay, yep. Even, and then we can duplicate this. Then even if we have an empty list, this we shouldn't care about that. And this would be, wait, if we got to an empty list before we run out of the combination number, it should just be an empty list. And then here, if it's less than 0, cannot choose a negative number. Okay, we're using natural number, so we know it's not gonna be less than 0. And then we have to do map x. Oh wow, this is, I don't know if we can. Okay, this is the base case, and then it will be, for us this will be map head, and then combinations of x minus 1, and then the other x's, which is the tail in our case, tail. Oh, and then this order needs to be reversed, tail, and then x minus 1, and then here plus combinations of x, and then the other x's. Now what you're trying to me, and then x's, x's. Address. Undefined name x's. Oh, okay, tail, I guess, tail. And then address. Negative NAT, cannot find an implementation of negative NAT. Oh, we cannot subtract from a natural number. I think we can't subtract from a natural number. How do we solve this? We can say it's an int, I guess, and then cast that's gonna be annoying. I guess what we can do is we can just have this be an int. We don't care really. So we need to add the minus less than 0 check, I guess, and then we can say here, we can say if x less than 0, then empty list, and then else we can do that. Finish starting address. Oh. Okay, if x is less than 0, and then address. Okay, so now I think we have it. Here in the generic combinations, we don't actually need that, I think. No, right? So where does generate combinations get called? So we generate combinations for the given bank. So here we can just say combinations, and then group them into, what did they say? I think they say 12. They said group them into 12, I think. Yeah, 12 digits. So 12. I don't think we need this. And then do that. Then that returns a list of nuts, and then we just map over them to find the maximum one. Oh, so okay, can't just be this then. Then that doesn't seem correct. But there's an easy way to test this, because if we turn the combinations to use two, if we tell it to use two combinations, it should give us the correct answer for part one. 7222. 17222. Is that a, oh, 17179. So it's not correct. Maybe let's maybe look at the combinations thing. Let's just make sure that that's working correctly. Example, and here just put this over, and then pipe this into show, and then print ln. No, it should be indent. Okay, then build. Okay, so the max combinations it found for part one are 89. Okay, it's not ordering the, okay, so I think it's not 89, it's supposed to be 98, and then for the second one it's 98, I guess, and then for the third one it's supposed to be 78, but it's returned 87, and then for the last one it's supposed to be 92, but it found 98, because yeah, it's combining the numbers to the left of it as well. So I think what the change to our combination function is going to be when we don't give it we shouldn't give it the whole list. I think so. Maybe we don't need this part right here. I think so. I'm not sure though. No, we do need that. Come on. It ends up being 89, which is correct, I think. Or 98. And then why would let's just ignore the, and then let's do this. I guess let's do in find max combinations. Let's just call this. I'm just gonna comment this out. Call combinations with a bank, which is a list of numbers, and let's just take this and paste all of it in, comma, and then pipe that into show, pipe that into print line, address. I think we can simplify this list. We don't actually need all of them. Let's just do 1, 2, 3, and then let's see what this gets us. Okay, 1, 2, 1, 3, and then 2, 3. 1, 2, 1, 3, and then 2, 3. 1, 2, 1, 3, and then 2, 3. That is correct. That is correct. That's what we want. But okay, so that's not where the bug is from. So this is correct, right? So if we do 4, 1, 2, 3, 4, and then this will be, let me just guess what it will be. So this will be 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and then 3, 4. Yeah, 1, 2, 1, 3, 1, 4, and then 2, 3, and then 2, 4, and then 3, 4. Yep, that's correct. So this is not where our bug is coming from. Let's look at our combined digits then. Combine digits. That might be where the bug is happening. Yep, I think this could be it, but let's take a look at it. Combine digits. So this should be 1234, but let's check it out. 4321. Oh no, that's wrong. That's clear. That's very wrong. That's where the bug is from. Okay, so here here we need to do a reverse. Maybe before we even get into this, we need to call reverse. Okay, yep, that's it. Okay, that's where the bug was from. And then let's just uncomment this and address build. So okay, 98, 89, 78, 92. Yep, that's correct. Let's just bring that up here. Let's bring it back to the original place. Maybe let's copy over from part one, I guess. What we just did is that, and then here we just do a sum, and then address build. Okay, 357, 357. Yep, this is correct. What about for my input address build? Yep, 17 and 79. And then here now they made a simple change. if we had used the combinations method, the combinations library on the first one, we would have just needed to change this from 2 to 12, right? Yeah, so let's do the example again so that we know we're correct. Example, address, build. It's taking a while. Compute. We're creating a whole በጣም ብዙ ሊስቶች that could be, yeah. ለኤግዛምፕሉ እንደዚህ ከቆየ ለዋናው ኢንፑትስ ጋና ኮምፕሊት ማለት ነው። so maybe we need to be smarter and not generate a whole list of combinations, because this was just 3 lines. What the heck is happening? Oh, we might have been wrong. Or we might need to tail code optimize this in the combinations function. Wow, this is not gonna work. We're just running it with the example and it's taking this much time. Fuck, okay. How can we be smarter? Because we skip numbers. We can't just slice out your undo number, because we skip digits in the middle of it. We skip digits. So it has to be a particular combinations, because it could end up being 8 1 8 1 8 1 8 1 8 1, and then just 12 eights would be the correct one. That's annoying. Wow, it's still going. I'm gonna wait for it for 1 more minute until 31, and then I can until it's okay. I think it's not gonna finish. Okay, let's start rethinking this. So what's the problem? Most likely the problem is the combinations function we have right there. So let's just try calling it with one of them, and see how long a single call takes. So combinations, and then this list, and then and then we're gonna give me 12 combinations of, I know it's gonna be correct at the end, but it's taking too long. I don't see any other bugs, but so let's do print, let's do show, and then let's do print ln, but here print. Maybe we should have been using strings. I guess we should have been converting the numbers into strings, and then that would make it easier. Maybe, I'm not sure. And then let's create a new terminal while we wait for that to finish. Address and build. Yeah, so look at this. These are way too many numbers. There are way too many numbers in this. The first combination is just the number itself, and then, by the way, how many digits is this? 1 2 3 4 5 6 7 8 9 10 11 12. Oof. In the example they gave us 12 combinations, so we're doing 12 combinations of 12 elements. Wait a minute, all of them are the same, aren't they? All of them are the same. I think all of them are the same. I don't know what's happening, but all of them are the same. Can you see this? It's just the same number repeated again and again and again. It's not even doing the combinations correctly. Oh, okay. At the end, it starts going over. But they need eventually. Okay, but there are way too many of them. Maybe we need to do a set or something like that so that we don't have any duplicates. Yeah, I think so. I don't know, these numbers are exactly the same. So maybe we need to unique. How can we create a unique function? It will just. So do they have sets in here? Idris set. No, it's just some. I don't know. Let's look for something called unique in this, or we need to. I guess we need to compare. We need to compare the first one with all the other ones because there are way too many duplicates in this. Think so? Aren't these duplicates? They are duplicates. Okay, I think I'm gonna try another thing. Let me just stop that. Just kill that one, and then let me comment this out. Comment that out, and then let's just give it the input and see what happens. Maybe the example was not computing, but the input might. I never want. Okay. Let's do this. So here, after we call combinations, or in the combinations itself, I don't know why it would be. Didn't we port it over correctly from this example? So if there is a if we just got to 0, then just return an empty list. And if there is we got to empty list first, and then we have a number, return the empty list. And then if we have a head, and then x is less than 0, or x is our combination grouping count. If that's less than 0, return an empty list. Otherwise, map over each combinations generated by n-1 given the tail of the current call, and then add the current head to all of those, and then at the end append call combinations for the current tail as well, so n times x's, so that those can be combined to and then I think that should be it. But maybe we need to add a unique. I thought combinations were supposed to be, I guess permutations are the unique ones, right? Yeah, this got logged way too many times. 7, 6, 7, so I don't know, to solve it, I don't know if, I think the combinations might be what's taking a whole bunch of time, or it could be the find max loop, because that could also take a bunch of time. So I think what we need to do is call something called like unique, right? You need to create a function called unique, and then it will unique. It's gonna take a list of list of nodes, and then it will return just again it's just gonna return a list of nothing, so hopefully, but this time they will not have any duplicates. Yep, I think so. So unique, and then if that's an empty list, it's gonna be an empty list. If we have a I guess this doesn't matter. If we have something, if we have a head and a tail, we can say we can say list, or how would you duplicate? We can't filter because we'll be filtering out ourselves. Come on, my brain has stopped working. Okay, we can't do a filter of the head equals the rest of the tail. So we can do this, I guess. We can do head, and then concatenated by alternate this, or we can call filter. Where head equals and then give it a tail, right? I can say something like this. Does this always need to be parenthesized? I guess it does. Okay, so we filter out all of the ones that are equal to the current head in the tail, right? And then we need to call, and then we call unique then you call unique on this. Is that right? Is this how you do it? Not sure. I think this might be it. Let me call instead of calling it here, I'm gonna call it, let me comment this out, comment that here, and then I'm gonna call unique and say stop build run. Oh, the unique is taking way too long now. No, unique is taking even longer now. Yeah, I don't think this thing ever reaches a base condition. I think it's just recursing because yeah, I think what we need to do is something like this: filter and then unique tail. Is this how we talk about it? Okay, I think the unique function is now working correctly. So this is different from this. How is that different from this? Just I'm gonna paste them here and I'm gonna paste them here and compare. These are all the same. What the heck? Right? I think the ones are what's causing the problem because we have a lot of ones. Even though they're only being combined once, they would create a lot of noise. I think let's just forget that. And let's try a simpler example without the ones. Let's try this without the ones, and then let's try this. Let's just say I guess 4 in here. I don't know. Then Idris build. Okay, so this shouldn't be the case. Let's forget about unique. Build. So 9876, 9875, 9874, 9873. Yeah, so the previous version was working. It's just taking too much time. So we don't even need to do the unique implementation. I think I'm just gonna do this. Let's see how long generating the combinations takes. Let's see where is the bottleneck happening. So let's just take parse input, which will return a list of nodes, and then we're gonna call find max, and then let's just call, instead of doing that, let's just call this here. Nope. Let's just call this, and then and then x, or I guess bank in this case will be that, and then we can say show here, and that will be a string. And then let's see how long generating the combinations takes. Oh, it's taking a while, so that's the main bottleneck. Yeah, እኔ ጋም እንደዛ የሚፈጠር ይመስለኛል እዚህኛው ጋር። I'm just gonna ask ChatGPT. Oh no. Tail call optimize this. Okay, Yeah, this is annoying. It's taking a generating the combinations is taking a while, but I don't know if there is even a way to do it without without just without generating the combinations, because like I say, like I've been saying, it skips numbers in between. So we have to check each combination of each number with like 12 other digits from the list. We have to keep doing the same thing. I don't know if that's the approach you used, reaction, but yeah. Okay, I think it came up with a tailcore recursive version. Maybe this will speed it up for us, I'm not sure. But in advent of code እንደዛ አይነት ነገሮች ማለት የሆነ something you have to optimize ከሆነ, if you're optimizing anything, your solution is wrong. So maybe that could be what we're facing right now. Maybe our solution is wrong from the start. I can't even stop this. What the heck? Stop. What the heck? It's not killing it. Maybe PS. Oh. Next. Nope. Grape press down. Grape. Part 2. Nope. Part 2. And then let's kill that. Yeah, by the way, it compiles to Scheme and then we're running. We're technically using Lisp in this one. Okay, we just killed it. Okay, so let me just clear that. We just need one down, one. Let me run it again. Yeah, still taking a while, even with the tailcall optimized version. If I say give me combinations of 2, that still takes a while. What? Shouldn't be the case. Let's revert this change. Maybe let's go back to our own combinations implementation and just convert it to 2 and address. Even generating 2 combinations doesn't work. The heck? It said something about a bug in here. Still takes a bunch of time. I'm just gonna remove this. Maybe just keep it to 1 number, but see how long that takes. I think there's a bug, I don't know. Why aren't we seeing anything? Okay. Let's put starlen then contents. Let's just do that. Whoa, come on, what is this? Oh, we're reading the inputs. Come on, should be reading the example. Okay, yeah, it should be working correctly. And then let's do trial bank. Let's actually try running the first one. Actually, with the let's do that again and see what difference that makes. Paste that in, save. So in the first one, we were grouping them by two. And then we were not. We are. Let's do that. And they find max. Yep. And then we were doing this. And do that. But here it would be two instead. Let's just build that. It still takes a while. Okay. Now it's working. So let's just do that. And build. Now it's just working. And then let's do some. And then let's do that. Right. And then let's do build that. So 357. We're class for it. Let's switch to the input. The inputs are way too long, so the combination just takes a whole bunch of time. It works. So now, just work when I turn this into a 12. Come on. Just build. It gets stuck. The numbers we're getting are like extremely large here though. Yeah, maybe that's the problem. But we're also using like a very slow. We're not even compiling it to machine code and stuff, so it's really slow. So okay, we're gonna cross the 3-hour mark. That's bad. ከሶስት ሰዓት በላይ ሊሆን ነው የዛሬው ስትሪም። Don't know. We find the max combination. First we combine the digits. Maybe we can join this into a single operation. The combining and the comparison into a single. We don't have to do a separate map. It doesn't help us that much though. I think it will. Let me just try that, I guess. It's not gonna help us, I think, but maybe it will. Let's try the accumulator and x, and then we're gonna call maximum accumulator or combine digits of x, because x is what's x? It's a list of natural numbers, not. And then yeah, hopefully that will help us. Stop that. Pain. Here. Kill that. And then just build. And again, still running with the example. Yep. What else? What else? What else? What else? Maybe this stuff, instead of doing a string conversion, this is, I don't know. I like that. I like that. I don't want to change that. The combinations is the biggest time drain. Sweet. Maybe we should follow the, I guess that doesn't make sense. Excluding, you still would have to generate a combination for that. Be like, we can end up with, I don't know, I think let me just do open the app, that document, double click to our notes. So yeah, we can end up with a number like this, 8181818181, and then the maximum for this, let's just resize this, and then the maximum for this would be all of the 8s, or some number could be like, I don't know, 97979, and then so for this one, and then 999, and then for this one, the maximum, like if I say the maximum 5-digit number, it will be the 999, the 5 nines, 1 from the start and then the 4 from the end. So we can't just easily come up with a way to split the number as a digits and say, look at the only this ones and that one. So we have to, I don't, and it's like I'm thinking about, do we actually need to do a combinations? But from this, I think we need to do a combination. We need to create, maybe the thing that's causing problems is we're creating a giant list of numbers, and maybe we should combine the combination generation with these combined digits and determining the maximum stuff. Maybe we should do that, I think. How can we do that? When is we don't even know when a combination is done. So maybe we can wrap this with combined digits, and then wrap the other one also with combined digits, and instead of returning a list of nuts, and they will return a list of nuts, and then we wouldn't need to do the mapping, and then we can just directly do a fold of nut maximum. I think that's correct. But yeah, so I think we have to do a combination. I'm thinking if we, I'm actually wrong about the combination, but it seems like we do have to do it. Let me do that. Let me stop this. Let me stop that, and I think let's, instead of returning a list of nuts, it will return a list of nuts, and then here we can call combine digits. Combine digits. Okay. And then in the find max combinations, it will just take a list of nuts and it will be nut dot maximum, and here it will just be power, but that's causing a problem. Oh, okay, and then we can do the cons operation here. Oh, we can even combine the, so this would be not dot maximum, right? And then at this point it will just shoot 0. I don't care. And then 0. It's not gonna work. It's not gonna work. It's not gonna work. We are losing the recursability when we do that. But this should do it, I think. Right? So it will return a list of nuts. But here, and then we can say this is a, we can just, but we can cons it. What's wrong with consing it? But that's, the combined digits on the other side would also be let's undo this. Maybe they start doing it again. So okay, that's that. And let's remove combined digits. So this is a separate array, and this is also a separate array. So what we should be doing is mapping, but that's not gonna help us. That's not gonna help us. It's not gonna help us. It's not gonna help. But combinations is now returning a, it's not gonna help us. Yeah, it's not gonna help. I don't know. I don't think we're gonna solve this one. Come on, I guess. But we're gonna get knocked out in the third day. Come on. It's not gonna work. So maybe we can be smarter about how we for which numbers we do the combination. So maybe we can just sort we can get the first 12, the largest 12 numbers, and then just do the combinations for those 12 numbers instead of doing it for the whole 15. The largest 12, the largest k, right? Maybe that's the way to do it. Is it possible to try and get each digit separately instead of generating all the perms and finding the one that's higher? So for the 2-lane array, you just have 2 loops over the inputs. Yeah, and then for yeah, I think yeah, that would be possible, but I guess I don't know how for the 12 one. Um, it's a bit that the combination is doing the exact same thing as the for what as what the for loop would do, but like you said, the problem with the combinations approach I'm using is I'm generating all of them, and there isn't an opportunity for me to do an early return and get stop doing the combinations when we've got the largest one, when we've like but yeah, but to get the largest one we need to do all of them, right? But like yeah, there is an opportunity to do an early return. That was what I was trying to do now, but uh, and then yeah, to Idrat's question, what are you using today? We're using Idris, this language here. I don't even know if they have an official homepage, but this is their documentation site. No, it's not Idris Alba, Idris. Yep, this is what we're using today. But yeah, we're not solving it, and we're over 3 hours at this point. I think maybe we need to filter out the k numbers, and then that's what we should be doing. That's the number for which we should be doing the combinations, not all of them, because in the main input, if we look at the main inputs that input.txt, yeah, this is way too long. So if we do the combinations for each one of them with each other one, and then for chunks of 12, that's gonna I don't even think, yeah, that's way more. It's gonna take way more time than the example, and with this approach even the example is not running. So how do we filter out that? So if let's give it some kind of allow list, and then we can say this list dot not. This will be some kind of, not where to add it because it did the formatting, but let me just remove that. Then let's do allow and then allow here, and then when you call it, you should provide the same allow that came here, and then only call this if if x, I guess we can do contains or something like that. List dot contains. Is there a contains? Contains. Is of function takes two lists and returns true if the first list is contained wholly and intact where within the bounds of the second. No, we just want to check a single number contains or has If we're gonna say contains allow x, then do that, otherwise just do an empty string or empty list. Like this, but they don't have a includes, maybe includes. Let's look at the prelude, I guess. Let's look at the prelude. Yep, prelude. And maybe basics or types. So this is where map and other stuff is defined. No, it's not. So let's check for contains indicate inputs, infix, inputs, into bool. Nope. Let's go back. Equal or includes. Max, mean, comparing to here. Show IO interpolation interfaces. This is where map is defined. So this is where map is defined. Still contains in map second, map pure, not map what we want. Yeah, it's not here. Let's create it ourselves. So it should be something like this: contains not a list of not, and then we can say contains x, where we can say filter x. Or maybe they have find. It's just a filter, I guess. Types, prelude.types, filter, map, maybe tail, either links plus link, filter, tr, filter, links, reverse, nope, mapping up there, but maybe element, check if something is a member of a list using the default boolean equality. Yep, that's what we wanted. Okay, if element and allow is a list. What's the order of the operators here? Not, we need to give it the type. So element, I guess this was the list. Not, why can't you just infer that? We also need to give it the function, I think. So it expects a something that's gonna take a lm by, I guess, maybe. And then the type. Maybe somewhere around here we need to pass in equals as well, because that's how we want to find it. Build the package. It's saying not the end of the block into a check indentation. Okay. This is what our block is doing. Why is it complaining about nothing? What is that here? But is this call correct? Not even sure. So this is what's messing it up. We need to do this. If I don't do that, it's okay. If I do that, if I add the no, I guess it's the double equals. That's why it's okay. While processing that, it expected a so let's look at the function definition again. Give it the equality function first, okay, and then allow, and then this. Still the same here. So the foldable is a list, and then the type is an int, and then that's x, and then allow. It's not making things up. I'm just gonna create my own function. Ugh, come on. Contains list of nuts, and then a nut, and then a bool. So contains excess filter x, where x equals y, let's call it y, x equals y, and then let's pipe that into strings. And then let's pipe access into that, and then let's pipe this into greater than there. Let's just remove that. Contains allow, and then the current x. Should we yeah, should we, that's what we're basically saying. there. So we're saying if the allow list contains the current X, which is the current head of the list, should we do the combinations for it? And then here we need to create an allow list, in something like that. Allow is gonna be empty, maybe. Yeah, then we can pass in the allow here, or we can pass in the allow here. Okay, so now we just need to come up with a way to get the allow list, which should be map, or no, it's gonna be sort or something like that. Do we have a sort? We don't have a sort. How can we not have a sort? There should be a sort. Address sort. Okay, just selects. That's actually okay. That's actually okay. So you just go over from the left to the right, selecting the largest numbers. That's actually a smarter way of doing it, right? But you don't know, like, okay, you have 12 spots, so all of them will be competing for 12 spots. So you can go over the list, and then I think let me just try the allow list approach, and then I'll do that. I don't think this will work, to be honest. Sorting in address. There is a sort function. I didn't see it though. Maybe it just didn't autocomplete for me. Sort bank allow, and then let's do this. Okay, it exists, and then we gotta do drop the first 12. Drop first in from list brush. Drop, no, select. Okay. I want to see the sort function in action, so I'm gonna say 4 3 2 1, and then show when they print line. Okay, so we're gonna drop the first bank length minus 12. Then drop length bank minus 12. Oh, cannot negate. Okay, what does this return? Not, so we can say cast, I guess. Then give it, tell it to be an int, but drop only takes I guess we can, I don't know, I'm gonna hard to code it for our example for now, because to just make sure it works. So if we have 15 numbers for this for our example, we need to drop the first three, right? And then let's say here drop 2, see what that looks like. Yep, okay, that's what we want. Then let's do this. So we have an allow list, and then we're gonna only look at the 12 largest ones. I don't know if this is gonna make a difference, but hopefully it does. Hope it does. It does not. So we're gonna need to use a sort function. Basically, just compare them, I guess. We need to do a merge sort. Compare each group of pairs and then reduce it down till we get to 12, right? Yeah, I think I'm gonna drop the combinations kind of approach. This is not gonna work. This is not gonna work. Yeah, forget about this. Forget about this bullshit. Forget about this bullshit. Stop. So this is what we're gonna do. So let me diagram this. So okay, let's say we have 1, 2, 3, 4, and then we're asked to find the largest. So we have 1, and then we've created we've basically just separated them out into a list. So this is what we have, right? And then what I'm gonna do is iterate over this list. Start from the left. The left. Our base condition is gonna be, so we have this, and then we just compare. Can't you okay, yeah. And then we're gonna compare like which one is greater. So it's gonna be like a merge sort kind of situation. And then we just add 2 there, right? And then we do the same for this one. Create then do the same. And then for this it would be 4, and then yeah, I think this is what we need to do. And then so, but we don't just go down until we don't fully enumerate all the values. We don't go down until like there's only one number left or anything like that. We keep on doing this process again until there are 12 digits left. So right, would that be the largest number we can create? Can that make sense? So if we compare 9, so we lose information. That's not gonna work because if this one was 8 and this one was maybe greater than the other one, so at this point if this one was 9 and 8, we'd just drop 9, and then 8 would be lost, even though it should be the next one next to 8. So this is not gonna work. Maybe we have to do this for every window, or for every we will just be recreating combinations if I'm thinking about it. But so is this how you did it? I think. Yeah, that did not work, I guess, sorting them and stuff. Mm. So compare each one with the other one next to it, but what if we do that? What if we do instead of this? So we would also have this and this, so that we don't lose any numbers. So each, uh, if it wins, it will stay in the game. Yeah, so what if we do that, right? So this one is like 9 8 9 8 7 6 7 6. Okay, so 9 8 9 would win. If 8 7 8 would win, and then 7 6 7 would win. What if there is like maybe what if we do like something like this happen? So if there's a 2 and then there is a 2 in here and then there is a 1 here, and then we would need to create a separate box for this. Doesn't make sense. This is not gonna work because here 6 would win, right? So here 8 would win and then 6 would win, and then here again 6 would win. But so we should, and then we need to keep track of numbers that we've already added to the list. It's not gonna work. That's not gonna work. Even if okay, so yeah, it's not gonna work, and then or we don't add it, or just 6 wins. Even though like 2 should be the number that's supposed to be here. So yeah, it's not gonna work. So this is not a good idea. So it's not a good idea. Just come up with another idea. Let's maybe explore the sorting again, I guess. The sorting. Wait a minute. We only need to do the combinations for the largest one, for the largest digit, right? I think that's what you're saying here. Yeah, I think it should drop all 11 of them, and then the only allowed one will just be, because whatever largest number we're gonna get is, it's obviously gonna start with the largest number. Is that always true? No, it's not always true. For like for example in here, the largest number we have is 9, but the largest possible like 12 digit sequence is gonna start with 8. Yeah. But maybe I should do this too, to just make sure that our allow list is working correctly. Let me just stop this, or kill it, I guess. Kill. And then this one is again just build, and then build exact. maybe it gets stuck in an infinite recursion call. No, it shouldn't get, because every single time we're taking out the successor, and then we're basically subtracting 1, so it should eventually end up at 0. What if we drop all 12, I guess? Well, and the allo list is basically empty, right? Or let's just give it, I don't know if the allo system is actually working correctly. Let's give it an empty list. Okay, it's working correctly. It does do something, but of course it's not the correct solution, but it's just manually hardcode it for the example. So the allo list was 9 here, 8, 4, 8 and 4. Start this, and then do that. It's not working. Yeah, we finished part 1. We got stuck on part 2 when we finished part 1. I think there's just the best way to do this is to combine the junction combinations with finding the maximum one, but I don't know if that's actually gonna solve it. Let's just do IO stuff to this, so that we can know when we're passing each step. It's just not do. And then just do that. What's something like this? I don't remember, but let's just undo that, I guess. gonna be wrong, but 12 combinations is a lot. Of stuff. Maybe let's go out to this approach again, same something over there. There's basically to just make sure we don't do the data loss, we will just basically have to compare each one with every other one. So, and then but we also need to preserve their location. So I think let's do this. Let's sort it. Let's sort the number. But first map over each one and keep the index. And then so map over. The first step is gonna be map over each one. Keep the index so that we can know where they are in that 12 digit sequence. And then on the second run, well, this is how we can do it without doing combinations. So let's just stop this. I think map over, keep index, sort the numbers, right? Sort numbers, and then drop the last links, the last links minus no, what am I thinking? The last links minus the current like, I guess for our case it will be 12, the current window we've been given. And then finally, to rearrange that 12 digit number, we can just create a new list, but this time it's sorted by the index. So sort again by the index instead of the, I think this should be a simple operation, and we don't need to do the combinations. It's just sorting. We just do 2 sort bys and a single drop, and then we have it. I think that's gonna be it. And then that's gonna be it. So we don't have to use this find max stuff. So I think maybe, so I need to create a, so I'm just gonna do it here, I guess, because we're not gonna be using those functions, I don't think. But we do need to find, no, we don't need to find the max. Yeah, we don't need to do that. So we just do this. So we have a list of banks. So we're gonna say find max solution for each bank, and then I'm gonna create a new function here. I'm gonna call it find max solution. It's gonna take a list of natural numbers. It's gonna return. It's gonna return a natural number. I'm gonna do the whole process in a single function, I guess. Yes, okay. Find max solution, and then we have the bank. Okay. So it's bank is equals to map with no, okay, so bank is bank pipe map with index, right? And then map with index, like it will give us the index and the current X position. Then we're gonna create a tuple out of this, index comma X, right? So this is the first step. So map over, and then we keep an index, and then now we will sort, but we will do a sort by, I think ChatGPT said we we can do a sort by, so sort by, yep, and then we can do, oh, okay, we have to do return something like this. So we gotta say sort by compare. I think there is a compare function, so we're gonna use compare. So sort by the index comma length, but now we don't care about the index for now. We only care about the index, the number, and then this will be sort by is actually gonna take two values if I'm not mistaken, right? It's gonna take two, yeah, x and comma y, so it's gonna be x and then comma y, and then I think there is a compare function if I'm not mistaken. Compare x y, right? It is not for now. Let's just tell it that. Alright, we'll stop complaining. Oh, nice, there is a compare function. Beautiful. Okay, so and then after this, the second step is to drop the last length bang minus 12. No, drop the first I so yep, that's let me just, I'll switch the type again so that the type errors will go away and we can see that that's actually correct. No, it's not, so I think we need to parenthesize this. And then what is this? Oh, you can't subtract from a not error. This is annoying. For now we can, I don't know, we can just hardcode it. Should we hardcode it? Because I don't like doing that though. I don't want to do that. We gotta figure out a way to subtract a natural number. So this has to be a not, so we can say we can make this be an int, the int, and then now the error will be something different. Yep, type mismatch, and parenthesize that address, and then we need to find a way to convert these lengths into, I think there was a cast thing I used when I was working on the disassembler stuff. Mismatch between int and cast. I gotta say something like this: cast int. Something like that. That's the extra parenthesis. Address. And then address. It's saying to create something like that. And then address. Subtract not in address. There must be like a floor. They must have like a minus. Okay, there is a minus function. Oh, we have to use that minus function instead, I guess. So it should be minus length and 12. Okay, there is a minus function. Nice. Okay, so we dropped the first three because this is gonna be 15 minus 2, and then we're gonna sort again. But this time we'll be sorting with the index. So this will be, I'm gonna still name them x and y, but x, y, and then finally we need to map over each tuple x I guess underscore comma x, and then return the x, right? And then here this could be a not. So, and then finally we call combine digits on it to get a single number. That's it, I think. Find max solution. So we're no longer using the combination stuff as I guess this should be a map. Yep. Just I'm gonna delete all of this stuff. Hopefully not also being used, right? Are we using contains anymore? No, we're not. We're not using this. Let me just run this. Nice, okay. Is that number? No, it's not. It's 303. Let's not sum them up, but let's have them be a list, and then we can show. Maybe it's because the combined digits will just assume their index, but since we're now they could be like from different indexes, right? So let's also look at this. So let's not, I think the bug could be in combine. It could be in combine, so I'm just gonna comment those out, and then let's look at the lists, pairs of not, and then this should just return a string, and then this show, right? And then let's boom, 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 boom. Okay, let me just do that. Then build. Okay, so let me just copy this, paste that in here. We can say it. So this is the max we found for the first bank. Let's go back, find that, and then do that, find that, and do that. Okay, so this is it, right? So bum, 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 bum. I'm gonna comment it out. So okay, so this is 9 8 7 6 5 4 3 2 1 1 1 1, and then this is 8 1 1 1 1 1 1 1 1 1 9. Okay, this is correct. And then this is 3 4 3 4 3 4 3 again, 4 again, 3 again, 4 again, and then 2, and then 3, and then 4, and then 2, and then 7, and then 8. No, this is wrong, huh? Yeah. So why did it end up being wrong? Why would it end up being wrong? When we did a sort, yeah, so this is not actually sorted with the, so the other ones were sorted, so let's find 0. Let's find 0, or 4. So these 4 didn't get to be part of the maybe it got dropped, maybe the dropping, our dropping logic is, because this is at 0 1 2, so there should be a 2 4 here. Okay, there is a 2 4, so it's at the index 2 and then the number is 4. Let's actually see what combined digits is returning, because yeah, let's do that. It'll be easier to debug interest. So this is returning this. Let's so this is correct, the second one is correct, the third one is not correct for some reason, and the fourth one is 889111. Okay, the fourth one is correct, so there is something with this one that's going wrong. I think maybe the dropping logic we have here should be something like maybe it got dropped, I'm thinking, because so let's do let's do a minus 11 or something, or 13. Could be an off by 1 error. Okay, let's do 13. Yeah, still 34. Should be 43. Why would that be the case? Okay, not a method. Which language are you using? We're using Idris. Which language are you solving it with? Have you done part 1? Yep, I used the stack approach to do it. If I'm optimizing it, then okay. Otherwise, I tried making a string of 12 rings. Like if the current string back is smaller than the current index, I think then pop back and push the current string. So like string max what jolt, zoom in join, and condition was while blah 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 blah, and then is more join. Yeah, could be something like this. But I don't know. I think the current approach I implemented would work. This is just a small bug here somewhere. I need to figure out. Maybe the map index function I created earlier. Let's look at that. Okay, so that should be correct, because maybe let's just look at them after sorting by the max index, right? Okay, so let's do so at this point list not at this point we should see 0, 4. Let's see where 0, 4 is in this one. And then let's go here, find that, and then break line on that, and find yeah, so there is a 1 3. Where is the 0 4? Oh shit, okay, so this 3 is getting accepted. Okay, that's annoying, right? So there are different 3s, so when it's sorting them, this is not being dropped for some reason. After sorting them, the first 2 values will be 2 and 3, but we have multiple 3s, and then the other 3 got sorted before it. So here we need to do the sort by some combination of the index and the value. Is that what I'm thinking? So yeah, let me go over it again. So map with each one, map over each one, add an index, sort by the number, not the index. And in this situation, we can end up with a solution where we can end up with at a point where we have 1 3 and then 2 4, and some of the 3s could be in front of the other one because they just got sorted with the index. They just got sorted with the number, not the index, because these 3 or the other 3, one of the other 3s could be the one that got dropped. So that's what I'm thinking. They ended up at the front of the list by coincidence. And then sort by. So the drop by, I think the drop by should be, it should be a filter. It should be a filter, right? And then the filter, we're gonna, okay, I think I have an idea. So the drop by should filter them. So we need a step in the middle here before we drop. So how we drop the list shouldn't be just what's at the front of the list, because that could end up being different. Our sorting logic should be, we should run the, it's gonna be the same. I was gonna say we should run map index again, and then delete the ones with the index of with an index, let's say greater than 12, and then we reverse it, and then we drop the, this drops it from the front, right? Or does it drop it from the, we checked earlier, I think. Delete that, delete. Let's see, drop here. Was drop implemented here? Or index drop. It should be in here, I guess. Drop. Nope. Map is here. What map is here? Okay, so I think ChatGPT is the one that recommended drop for us. So it just it always drops it from the first. It's in the prelude. This one, drop. Maybe it's yeah, but somewhere around here there's a drop. Could be none. I don't know. So if we just sort it again, if we sort it by the index, so here we don't do the drop after, we do the drop after the, so we sort by the index, and then now we do the drop. That's what I think. That's what I'm thinking. Right. And then we need to drop it at the end, though, in this case, because if we drop it at the, if we drop the values at the, we can reverse it and drop it. So I guess we can. Is there a drop from start? Drop first, last end from list. We might just need to do, yeah, so we just need to so drop last will be drop length x minus n. Are we dropping the last? Are we dropping the, so if we say drop 12, so in this case it would just be drop 2, but let me just do that, just 12, this again, build it again, then we'll do this. drop. Let's run the drop here. I think maybe a bit better do it. Let's press it to do it. Let's do reverse. Then reverse again. Maybe now let's just combine the digits and see what this looks like. What? Reverse will just return any stuff. Let's do minus here, like that. Dropping it more. Oh, yeah, of course it's supposed to be. Yep. Build. It ended up even being even more wrong, so let's look at that. Let's look at that. So 9876 81111, and then we're dropping the last one, so that's correct. And then maybe what if we don't drop it, and let's just see what it looks like if we don't drop it. Anyways, let's not drop anything and just do the sorting by the index. So all of these are supposed to be correct, but the things we're dropping could be in the middle. So bad boy, if we do the drop like I said earlier, something right here, let then this becomes shorter, but these ones still are causing problems. Yep, this one is correct now. We're so close. I don't know, maybe this solution is also wrong, but I don't see any problems with it. But this one is, for example, I don't know why this. So this is the correct number, and then this is what we're getting. Right, so 4 3. So if I just remove this, yeah, so if I start 4 and do this, no, it doesn't end up being correct. If I delete 3 in front of this, it's nowhere near close, it's nowhere near correct. So 2 3 4 2. It's just this should be, these are reversed for some reason, or these 3 are reversed. So until then it's correct. It's 3 3 2 2 4 4 3 3 2 4 here. And then it's like starting from the first 4 digits are not what they should be. Think about this. So when we sorted them, it ends up being like 2 3 3 4 4, stuff like that. and we drop it. We drop the smallest three numbers, which are 2 2s and 1 3. But for us, I guess this is ending up as being something different. The smallest three numbers should be 2. Yeah, all of them are dropping 3s. If we see this one is dropping 3, this one is dropping 3 numbers, this one is dropping 3 numbers, and this one is dropping 3 numbers. I'm gonna say, what if we hardcode and we just gonna hardcode 3, drop 3 numbers, and still causing a problem. For some reason we're dropping the numbers that we're not supposed to be dropping. So after we've sort of compared them by the value, the first two numbers here should be not comma not. Whoa, come on. Okay, so what is this? This is the first. No, this is where the first one ends. The second one, this is where it ends. So 2 2 2 3 2s. 1 2. Oh, so the 3 2s get dropped, and then we're left with this. It should be like some kind of a weighted sort, not just the values themselves, but multiplied by the index. It doesn't make it. Maybe here we need to compare by I, and then let's call this J, and then compare it by I times J, and then Y times J, Y times X, and then Y times J. Maybe something like this. Doesn't make sense though, to be honest. Okay, 3, let's say end up being 0. Oh, 2 3. Oh, these are the first 3 letters we should be dropping. 2 3 2. Okay, I might have done it. And then we should do not address beyond. Nice. Whoa. Okay, no, the other ones are wrong now. Ah, shit. Right? This one is wrong. It's 765, blah blah blah. Yeah, we ended up dropping 9 and 8 because they were at the start of that. Oh shit, this is bad. This is bad. But this is correct, right? This one is correct. So maybe we should do this. We should do the weight is important, but it's not that important. It's like, say, no, I mean the index is important, but it's not that important. So let's do it still would end up being how can you sort by 2 values simultaneously and then just weight? I guess that's the weighted stuff I'm trying to do, but doesn't really make sense. So yeah, it ended up working for the 4-3. Like I said, I think what if we do this? So let's do the weighted stuff, and then let's wait the drop until this, and then do a reverse. Hopefully they'll end up at the end. right? So yeah, this one is still getting wrong, I guess, being wrong. But we're also losing 9 from this one. And this is also ending up being incorrect. There any solutions time from just number possible? How about yours? Build one digit at a time, from left to right. Try to grab the largest number available. Okay, so we just start from the left, find the largest one, put it in a list, then go over the list, find the largest one, put it in a list, find the largest one, put it in a list, and then until we reach 12. You just, I think I should just do that. But wouldn't this have the same problem we are having with the combination stuff? I feel like this would take a while, because we can end up like, what if we just added, for example, what if we just added 2 to the list, and then maybe something like this. So if which so two is so I guess we could go over the list, and then we can't add 8. What would we add, for example, if we just start at 2? This one would be just, so this one would work with that kit, but I don't know. Like number is then you find like 8 or maybe 8 at the end, but can you make 12 digit? Also, first you try to find a 9, and then next you try to find an 8, and then you try to find a 7 with enough position left to fill out 12 digits. So the condition will be so you can do the sorting stuff. The sorting stuff seems to work. It's just arranging them in the correct order is the problem you're having with the problem you're facing, right? So if we just don't do the drop, let's not do the drop, and then let's do this. So determining which numbers we should drop is the thing. But yeah, so we can come up with some logic to drop them. I think that's the best way to do it. So let me just do this. Let's look at them again. Lists, not comma, not then address, build, then copy this over, then find opening braces, find opening brace, then find opening brace. What about the index minus the doesn't work. The index minus the number minus the index. Won't work. But here, so for example, in here we would need to remove so 0918 0123, because finally we sort them by the, let's not do that, let's not do this, not do that, it's not correct. Oh, maybe instead of point sliding, okay, delete, find the first one, delete, find the first one, delete, find, delete. Okay. 9828. So if they're less than some, they're not less than that, then they're not less than that. So let's say if we, so we know that we're gonna need to drop this, but some of them are, like one of them is here. So what we need to do is, if their original position almost doesn't matter. I don't know why we should be sorting it by that though, right? Sort by index doesn't really matter. Sort by index, why does that, what is the sort by index? How does that help us? It doesn't help us anyway. Drop the last, sort by index. Doesn't help us. Does not help us. Oh, it helps us to preserve the position of the large numbers, because if we just keep it, okay, yes, that like number source they could end up at the front of the list. Like for example, here 9 should be somewhere at the end of the list, right? Or in the second example, yeah, so 9 is at the end of the list because we sorted by the index. But the problem is we need to drop the first 2 after we do that, don't we? This is complex. When you sort the index by the index, they get mixed into their original position. So what the heck? We need some way to have these numbers get sorted at the start, but so this will have like 0, index 1, 2 and 3, 0, 1, 2 and 3. So we need to check there's no way they can end up at the front. They will end up at the front of the list. There are just doesn't matter where the position is. I think I'm stuck. I don't know. I don't know. If I can figure it out. How long have we been streaming? We've been streaming for 4 hours already. uh, I don't know what this approach is, to be honest. I don't even understand it. You did mark the jolt, and then you took that, okay, 12, and then you did a for loop, and then while mark the jolt is not empty, and then mark the jolt back. Yeah, I think maybe we need to introduce a queue to this. I'm not sure. Fuck. Almost 2 times that. This is how it goes with Advent of Code. Intuitively, this seems to work. I don't know. It's just I don't know why it's breaking. Let's stop this one. Okay, I think the third one is what's causing problems. So this ends up being 0, so this is 0, the 0 is 2, and then the second one will be the okay. Wait a minute. I think maybe we need to sort it by the values again, or by the index again. So according to this is actually correct. So if we drop the first, so this is just the number sorted by their values. So here, if it's sorted by the values, then where is 9 then? I thought 9 should be at the front of the list. Oh, 9 is at the end of the list? What the heck? Is the sorting isn't even working? How does that compare? Oh, what the heck? This is shit. I was messing up my own. This should be sort by the number. So this should. Oh no, this doesn't make it. I was actually getting wrong result. Sort by the number. This is wrong. I think both of them are wrong in that case, right? And in the first one, 8 is the largest one, or it's not. Not 9 is the largest. Compare x and y. Yeah, and then at the end of the list we have 0. No. Where's the end of the list? There it is. 9 8, yep. And then here we drop the smallest. We drop the smallest three numbers. How does that not make it work? Let's drop the smallest. I think that's correct. We should drop them. We should drop the smallest three numbers. Drop the smallest three numbers. Drop 3. Then build. We still have 811 because it's gonna end up in a bunch of ones. So we drop the 3 ones at the front. Then for the next one, we drop the first 3 ones here again, right? Because yeah. And then now the end is, or we have 9 at the start of the list, and then it's correct. It seems correct. But for this one, for the third one, that's where the problem comes. So this 1 1, 3 1, and 5 1. That's not the third one. So this is the third one. No, 0 2, 3 2, and 6 2 are the smallest ones. So 0 2. Also, the first one is the index, and then the third index value 2, and then so these 3 numbers are what's being dropped. So these are the smallest 3 numbers. So this tells me that we should drop the ones that are, we should drop 3, but we should prefer to drop the ones that are closer, or their index is closer to 0. So maybe there is another sorting step here where we just, because we've already sorted them. Yeah. Oh, this one is not even correct. We're dropping it before. Is this how it was? No, it's not correct though. We're dropping it. We should drop it after. What was I thinking? Drop. Right. Drop 3, and then let me drop address yield again, because yeah, and then here. Where does the list end? This is it, and then followed by this, and then this. So okay, let me just run it without dropping, and then let me run it with the drop, so that I know the difference. And then that's without the drop, and then this is with the drop. Let's look at that. Let's look at this. So this ends here, the second one. The second one ends here, the third one starts here. Okay, so we had 0 2, 3 2, and 6 2. So 0 0 2, 3 2, and then 6 2, which is this one. But yeah, 6 2 is already part of the number we want to construct, so we don't want to drop that. So what we're gonna say is, I want to sort it again based on the index, or no, the dropping criteria is this is the dropping criteria. So drop should be index is less than or index number index. When we first do the compare, when we first do this first sort, we already have the 12, right? We already have the 12. We just don't know their positions. So because the first 12 of these, we know 100% that those are gonna be the ones that are in the final. That should be in the final output, right? So our dropping logic should exclude those and take out as many. Oh, should just we should do a take instead here, right? We should do something like map, or we should do a filter map where, and then we have to map index them again, right? No, we don't, do we? Yes, we do. So we just need to map index them again. Yeah, and then but this time we need a filter index, right? We need a filter index. I'm gonna ask ChatGPT to give me a filter index. Filter index. Yeah, filter with index. So here we need to do a filter with index, index, right? And then we have the index and the tuple. So what we need to do is, if the index is greater than I guess 12, because the largest one will be, then no, I guess just do index is greater than no, index is less than 12, right? And then do the sort by with the stuff we already have, and then let's do that. I don't know, I think this seems to be correct. I don't know, it's fucking annoying. It's annoying, this is annoying. Okay, filter with index. Yeah, why is it complaining? Of course, it's a single number, not nah, fuck, this is wrong. Why would that be wrong though? Let me just remove the right, because my idea is, once we've sorted them by their name, by the values, we know the ones that are at the end of that list are gonna be the ones that are gonna get removed. But that doesn't work, because for example, the number, if the number is at 9, right? If the number is at 9, okay, we're gonna be here, we're gonna be sorting by the index, so this should be ij. Let me look at that. Let me just undo this, undo that. let me look at them after they come out of this, after they come out of the filter. Yeah, and then if filter with index, so if it returns 2 it will keep it, right? Filter with index, okay, so 0, 2, yep, come on, and then let's just ignore that here, right? So if the index, because when we were just sorting them, when we were sorting them, let's look at that, let's look at this, and then let's combine them, because it will make it easier for us to view the numbers. Once we filter them by their index, what do they look like now? So okay, the end got removed here, the end got removed there, because why would that be the case? Because okay, so this logic is inverted. This should be greater than, because it's ascending order, the sorting is ascending order, so yeah, okay, so this should be greater than 0, 1, 2, right? Okay, seems to have all of the digits, and then if we sort them by their original indexes, all of the other numbers are correct, but this one is still messing it up, right? Fuck. It did the same thing that the drop was doing. It didn't do anything. We just recreating the drop with the, yeah, filter index action is just, it's exactly the same as what the drop was doing. So we're dropping the, so maybe we add a check with the number, so we can say if the index is greater than 3, and number is not, I don't know, that seems tricky, but a number is less than, I don't know, let's just say 4, I don't know, a number is less than 4, let's say this is number, this is extremely hard coded for example, but, and then it's probably gonna break the other one, so kind of an implementation of not is this how you do an end here? How do you do an end? Num if, how do you do a comparison? Oh, okay, so let's just say we actually know the original index, and so if index is greater than 3 and original index if their original index is greater than their filter index, or let's just do the num thing first, let's just say underscore num, and let's do that, but I think this will break the other examples. Yeah, it break all of them. But wait, maybe we can do something with this. We can say, because we already know that, for example, 2, it's like 0, 2, 1, 3, and then 2, 4, and then 3, 2. These are our numbers. So, and then their new indexes is probably this one is 0, this one is 1, and then this one is probably 3 or 4, because there are other 2s, there are like 5 2s, so this would be like 5, this will be like 5. Now 3 is all the way over there, because yeah, it's already like, it's at 5, it's at 4, it's at 4. So we want to include these 3, but what's the logic for those? So we gotta know that their original index, and then to the right are, will there be enough 12? Will there be? So we gotta say their first index, so their new index is 4. So for this one it would be like, to make sure it gets removed, we can do like their original index is at 2, so we can say, and then we know that we have 15 elements, so let's say 15 minus 4, 11, so that will be less than 12, because, so let's say, so the filter logic is, your current index, not the current index, but the filter index, where you're right now in the, after being sorted, minus, right, all the links. Okay, so 15 minus your current index, minus 4, which is 3, and then their current index is 4, right? I think 4. I don't know, there seems to be a check we can do with that, because what we're trying to make sure, but let me just try to think about this with words. So what we're trying to make sure is the numbers we're removing, are less than the maximum start position, or our start position, right? Or less than the start position. So the 3 numbers we remove, they have to match 2 conditions. Number 1, they have to be less than the max or the start, and then they need to have a low index, right? But that will also that will be correct for the 2 if we remove the 3 2s, right? What is it? And no, the numbers to the left of them, if they are less than the max, it can be to the, well, it can be from both sides, right? I'm going crazy. If the number is we know that this would need to be part of the, but for duplicate numbers, we need to handle, for duplicate numbers, compare their indexes. If the number is the same, so we need to create our own compare function, right? So our own compare function that will do, so that will take in, I'm gonna do this, so let's do this, compare, it will take an index, no, it will take a take two natural numbers, not comma not, and then it will return an ordering. That's what's called ordering, and then compare I comma num, right? So and then if so, and then it will take another not comma not, right? And then it will be j I comma num, and then j comma y should be I comma x. Holy shit, advent of code. I gotta get back to work. I need to end the call and do some work actually. Okay. So this is the comparison we're gonna do. If x is equals to y, compare I j, right? And then else compare x y. Right, I think this might be true. So yeah, let's do that, and then let's use the new compare function here. Sort by compare, and then let's call this compare tuple, compare tuple. And then here we can call compare tuple instead. Oh, compare. Why is this erroring out? It's saying I didn't. Okay, compare. Not compare, not compare. Yep. Okay. Yep. And then here it's also complaining. Let's not do that. Let's see what this looks like. I think we need to do this anymore, but let's just, I want to see what they look like, so I'm just gonna order this bundle. Okay, so we are still ending up with a bunch of 2s at the front. Right, so according to drop the last, sort the number, drop the last things, -12. Here we would do the drop, but if we do the drop here, we would be messing up with this. Let's now compare them with let's sort them with their original index again. Oh, okay. Oh. So these are I and j. Let's compare them. Let's sort them with their original. Let's sort them with their original indexes. R and j. Yeah, so it's ending up with 2-3 in front of it, which is exactly the same as what we were having previously, or previously we were just dealing with 3-2, right? And then the other ones seem to be correct. And then I guess what we need to do is, if we add back this, it will end up being wrong. Might just end up being wrong. But now what's different? actually code እዚህ ጋር በእነሱ በሰጡን ሩሎች it doesn't matter if the number we removed was this one and then we kept this one, or does it? It does matter because it will reduce it. So our comparison function could handle it, I think. It could do both of them. So, and then we don't even need to do, and then we can just I think if we create our comparison function correctly, if we, yeah, it could end up being, because what we're doing is we're sorting, at least it gets called with every other one. We know that this compare function will at least get called with every other one, or does it? Not sure. And then we can do something like, if they are the same, that's, I think that's not helping us that much. I think it was already, that was already true. Maybe if we change the order for those, if we invert that, so that the largest one would be the one with the bigger, the larger index would be first. Would that help us? Not really. But this 2 3, so this would be 4 3 4 2 4 3 4 3 4 3 4 7 4 8. No, that's not wrong. That's not right. And then let's remove this. Yeah, I think this approach, we need to scrap this approach and come up with another thing. Yeah, I'm gonna give up. I'm gonna give up on my approach, and yeah, I should have used Rust for this one. At least we could have የመጀመሪያ combinations brute force ይሰራልኝ ነበር. Because I gotta get back to work, I think I'm just gonna implement another approach. Where was the solution that I think? Let me just, okay, let's see this and see what we can figure out. So we gotta turn this into a string and something like that. Okay, this is indented, or this is gonna be the third approach we're gonna try today. Hopefully it will work. Okay, and then do okay, so we check if the string is less than 12. We return. Is this like a recursive? Why would we need to check the links? Is this being recursed? Then we create RI and maybe because it's Python, it's losing some indentation information where it's being copied. Let's copy this. See what that is. Comment this out and paste that in. Holy. But okay. So string max jolt, and then we have the size, and then we have our combination number k. We gotta look at for I. Okay, and then we iterate over. Okay, so and then for each one, while our string is not empty and a string the end of our string is not back. Why is this? I guess back would return, I'm thinking the last element of the string, but and then less than the number we have at the current index, and the max jolt size, the size of the our string we're accumulating, plus n minus I. N, what was n? N is the size of the original string minus I. Okay, and then it's going up. We pop the back. We pop. And then we keep adding the total sum. Okay, this how I do. I think for each for the we have a while loop inside. Okay, I think so. The iteration from left to right approach you guys are using could be correct. Is the correct one, I guess. So since you guys have already solved it. Okay. Let's go back here. You guys are not looking at slices. You're looking at the whole string each time. Okay. Yeah, I guess the rules. One of the rules we said was we wouldn't ask GPT for a solution. That's why I don't want to do that. But I guess today we can break the rules because yeah, we're past 5 hours now. Today we can break the rules because we gotta get to work, finish this up, and get to work. Yeah, it's like looking at windows doesn't work. So because we would like lose information if because this we think like 3, well, like 8 is the largest one, but yeah. So depending on their string position, depending on their position in the string, even if they're large, if they are the largest one, they also like they need to be there are like two considerations to add them into to add them into one of our 12 position slots, right? The number one, because we need our number, the final number we produce needs to be exactly 12 digits. We can't just take the largest number and pad it with zeros. So it has to be exactly 12 batteries. The number we produce has to be exactly 12 digits. So what we should do, the two considerations are, is it the largest number we are seeing in the current window or something like that, right? And then does it have enough elements after it to fill the rest of the positions, right? And then once we do that, that will like I think the reason I don't want to go with that approach is because it will force us to it would be like effectively we're doing a combination, because and that's the first approach we tried and that didn't go anywhere. So I think the new approach should be, so we have to like loop over and try to complete the sequence for after choosing the current one, right? Maybe the problem we are having with the computation, our like combinations approach we first took is it was just way too many combinations to calculate. So if we're smarter about the combination, we also included an allow list, but that wasn't actually working. That wasn't actually working. So we can't go back. Like we know that once we've chosen the largest number, so it has to be going from the left. So all the other numbers we add need to be from the left side of the list, right? We can't go back to the list. So what we need to do is find the largest number with enough position left, with enough digits, I guess, with enough digits left to fill the other 12 spots. And then we just keep doing this again for the 11 slots, for the 11th slot, and then for the 10th, and then for the 9th, and then for the 8th, right? We just keep doing that, and then every single time they can only look at the numbers that are immediately to the right of them. Yeah, so the loop is going to be find the largest number with enough digits left. So so the comparison function, now it's not going to be a comparison function, but it should be something like this, I guess. It should be the max. We just try to take the max, and then we filter that one out and try to make the max again, filter that out until we get the max with the index that's that's greater than the current step we're in, right? So find max for step. We can create a function called find max for step, and then call it 12 times, or loop it over the string, or I guess call it 12 times. And then each time we minimize the. I think that's it. I think that's it. I'm gonna do that. Free piano. So this is the third approach we're gonna try. And then I don't see any problems with it, because it's not trying to be smart like the other ones. It's just straight up doing what we're told, right? So it's trying to, so let's say find max for step, right? And then find max for step is gonna take a list of natural numbers and the current position we should be looking at, and it should return that not, and then we can just call this 12 times with the given bank. And then that thing shouldn't be called just so how do we know we need to know the length of the list, and then we can just subtract the index, and then we know how many others are left in the list, right? So if we're at 0, it's gonna be 10 minus, I guess it's gonna be 10 minus index plus 1, right? Because if there are 10 elements and we're at index 0, there are 9 elements left. So this is gonna be recursive. So find max for step. So the x's, this is the bank, and this is the current position. I guess this is for position, right? The step is something we keep track of inside. So find for position. So what we're gonna do is first thing we need to do is let links, bank links, I guess is gonna be links of the bank in, and then so let's just keep that, and then we're gonna try to get the maximum one. So max, or this is gonna be recursive. So, and then if we don't find the max, what do? We filter it out and call find max for pose again with the. Now we just filter it out and then call it again, right? So we need to create with bank index. So let's do map with index of I, and then comma and then I comma x, and then to do bank index, pipe that into lists, no, fold left, and then max. We need to get the maximum number, and of course this will start at 0. Fold L, we can say not dot maximum, and then I guess this needs to be like this instead, I guess. So it should be x, and then underscore y, and then maximum xy, right? And then this is the current max we just calculated. Oh, it should be an underscore. The current max we just calculated. Oh, my charge is running out, so after 100% now, and we are ما بعد موت أفتح we are under time limit, time crunch. So why isn't that working? Oh, we didn't give it the bank here, right? Come on. Okay, but let me, what else can I close? Because we're streaming the move, no, let me quit Telegram. Okay. I don't know why it's complaining. Maybe I'm just gonna, I don't care about the most optimal approach, to be honest. I'm just gonna, so because my piece is judging out that we're gonna break rules, so I'm just gonna ask ChatGPT to give me a function like this. So the function is, so give me a function that when given a list of nuts that will find the largest number possible. Give me a function that given a list of nuts that will find the largest number possible, given this, I guess, the largest number possible with enough digits on the right side of it, I guess, on the right side of it, to create with at least, I guess, with at least 12 digits available, or any digits available, and that this is part of the definition, with any digits available to the right side of it, right? Am I still online? Okay, yep. Hopefully I'll end it soon. Yeah, but this was today's today is making me reconsider the whole plan. I don't know why isn't this working. Come on, ChatGPT, what you doing to me? Come on, let me create a new chat. Or is it my network in address? What? Did my... Am I still online? Am I still online? I'm not sure. Okay. It's just... Is ChatGPT having an outage right now? ChatGPT status. My PC is gonna power off in like minutes. Oh no. Okay, increase there when creating new codex task. The fuck? It's not even reloading. Maybe we'll open up cursor. Stop it. And in address. Oh, I think. Oh, is ChatGPT working for you guys? I think maybe they just started an outage. Can somebody confirm? I'm not sure if I'm even online. Let's not in address. Yeah, like the moment we needed it most, it failed us. So let me create this function here. So let's use that example, or let me just do that, I guess, and then so using this, what we're going to do is, so we're gonna find solution is gonna use that, or find max solution is gonna use that, and then it's gonna get given a bank, and then it's gonna create a list with basically something like this, right? I don't know if that would work, right? Yeah. So I guess let me just finish it with ChatGemini. I guess using that function, create a function that will create a list with 12 digits, I guess. The function a number, a list with 12 numbers, and when those numbers are combined, I guess they would when those numbers would be the largest possible 12 digit number to create with a given list of nuts. But I think I might be able to figure this out myself. So I think what I was thinking was doing something like this: find largest with suffix, and then I would just call this like this. I think maybe that could work. Find largest with suffix, and then so what is n? I don't know how to define that. So length check n. Yeah, so n is the number of digits that we should have available on the left side. So n bank, and then basically just repeat this for all the numbers, right? So nope. I don't know. We should probably use a loop as I'm gonna do that, and then 9, 8, 7. But I don't know if this is gonna work. 6. Nope. 6, 5, 4, 3, 2, and 1. This is not how you define a list. How do you define a list? Address list. We have to do the cons. Come on. Okay. Really? We have to do a cons operation? Come on. That's stupid. Just to get all the commas and this here too, and then we can just do that. That would be wow. But still complaining here. Then I guess it should never happen, right? We should always get a number. What is this complaining about? And then we can say bank, I guess. Bank. What is it complaining about? Mismatch between nut and car. So, oh, I guess forgot. This is gonna be a list of. Okay, don't care. And then I want you to pipe that to combine digits. Hopefully this will work. Holy shit, combine digits. I don't think it will, but maybe let's hope it does. Because maybe I think we need to slide the window. Maybe combine digits here. Maybe I think we need to slide ማድረግ አለብን መሰለኝ I think. With exactly six numbers left, with exactly at least 6 numbers. So if it's like, if it gets at most ነበር ማለት የነበረብን at most 6 numbers. Oh no, that's not correct. This is not gonna work because it will include more numbers than we need. Yeah, so it's all gonna be 999. Oh, all of them are gonna end up being the same number. That's what I'm trying to say. All of them will end up being the same number. So what we need to do is slide the window over by the last one. So slide the window of the bank over by the position of the last one. So because we don't want to include that maximum value, we want to start looking from, so yeah, the greedy approach. Okay, yeah, something like this. I'm gonna give it this code indeed. Something like this, but we have to shift the bank to only, we have to slice the bank to include only the digits after the previous max we found, right? It should be something like this, but in a loop, and then we need to keep track of the last max. ChatGPT is blocked. I don't know if it's just for me or it's for everyone, but yeah, it's working for me. Okay, at least 12 things is kinda not right, because if you already got some numbers, then you need 12 minus the number of digits you already have. Yeah, I think you're right. Yeah, that's why this approach failed. That's why this approach failed. I think this is it, but RS save it, should be errors, and let's delete this. Let's comment this out for now, and find and slice. And then I don't want to split after. What the heck? How many functions did it create? So we don't need this many functions. One function should have done it. This Gemini is not good at following instructions. I guess it does whatever it wants. Okay. I don't like that it's including a bunch of maybes in here. Where is maybe? Let's just return 0 in those cases, because we know our input is correct. Or I guess in this case it's using it to signal when we're at the end of the input, so I think maybe we need it. Fuck, okay, so yeah, we need that one. And then find max solution, return a maybe not. Nice, it's working now. I guess we finally got okay. And then we don't care about the just stuff here. So this shouldn't be a maybe. It should not be a maybe. Just give me a 0 if you can find one. Because we're gonna sum it, zeros don't really matter. Then Idris. 5%. We're gonna die. I think these are all correct. 7, 8. Unison. No, Idris is not a good. Idris Abbalasha man. Syntax I think how much syntax I think we would have understood this. Yeah, okay. So okay, so instead of show, let's do sum here. I think now we should have the correct value. Idris. What are you complaining about? No, it's not an int, it's a not. And then let's do the build. Let's check this number, search for it. So that's correct. Let's run it with my input. What if it takes like a but I'm because you someone by input to run Zarago. Shit. Okay, it didn't. Okay, that seems big enough. Nice. But yeah, we didn't do this completely. But asterisks, no, I completed asterisks. The approach was I came up with the approach I explained the approach to the AI, but actually the final solution code is not mine, even though it's using some functions I defined earlier, but it's not mine. I'm not even gonna clean it up because my PC is gonna die. I'm just gonna commit fit implement die2 no what okay commit fit die3 part 2 plus so Zarita Marno Idris is not usable, even though it's a good language. It's not usable. We had to create like a bunch of our own custom functions to do like basic stuff, like to convert a character to a natural language, to a natural number. We had to create our filter with index functions. They don't have a map with index or filter with index. And then like in the previous approach, we had to create our own combinations function. The annoying thing is they have a permutation function, but they don't have a function to generate combinations of k elements in a list. But they have a like to take a permutation of elements of a list. But that wasn't useful for us. But yeah, I think that's it for today. Yeah, let me just close up stuff. Yeah, Idris is not good. No, I'm not gonna blame the language, but yeah, it was not a good showing for Idris. But yeah, let's see you guys tomorrow. I think let's go to the leaderboards. Probably Zari የመጨረሻው ነኝ እኔ. Let me see. I guess since I completed the last ones, that's still keeping me going. The የመጀመሪያ ሁለቱን ቀኖች ግን if this pattern continues, I'm gonna be dropping soon in the list. Yeah, so thanks everyone for being here. Bye. Let me end the stream.